anything that pops up.
Okay, sounds good.
Yeah, so just a quick introduction. My name is Martin Frigaard, and today we're going to be talking about developing and testing your Shiny application. Let me go ahead and share. All right, so let's get started. What I actually have here, I have the slides. What I'm going to do is I'm going to put the slides up on one screen, and I'm going to make sure that we can see the GitHub repo on the other screen, because this talk actually follows through some branches in a GitHub repository that I've put up. There's the link for materials, which Phil said he's going to share with everybody. But if you had access to Posit Cloud, make sure you check with Phil. If you don't, you should have this repo available to you. And the way that the workshop is going to kind of run today is that we're going to have a series of branches for this particular, it's a small application, but it's really just for demonstration purposes. And we're going to go through kind of the various stages of first Shiny application development, taking a very basic Shiny application and converting it over into our package. And then we are going to, once we kind of have that established, we're going to go through some parts of application testing. I'm going to talk a little bit about behavior development, behavior-driven development and behavior-driven testing. And we're going to cover some integration tests and hopefully get to system tests. It's a lot of material to cover, but I think we can do it. If you have any questions, like Phil said, drop them in the chat. I will make sure to I'll make sure to connect with everybody on the chat also if you have anything for me. So let's get started. Why are you in here? I'm assuming that I'm hoping it's one of these three reasons. You're either comfortable or consider yourself an intermediate Shiny application developer, but maybe you're not as comfortable with developing R packages. Maybe even kind of one of the frameworks. Golem is a common one. I know that we use at work. Maybe Leprechaun or Rhino, and you're not sure which one to use for your particular circumstances or your environment, or you're very comfortable building R packages, but you're wanting to kind of transition that into developing Shiny applications, and you're curious how those two things will bridge. The benefits of having a Shiny application in an R package is it's easy to test. There's a testing framework kind of already in the R package ecosystem. It's also easy to share. It can be installed, loaded in another RStudio environment. And the reason that I think is kind of the biggest selling point is it's just, where everything belongs. There's no more, where do I do these particular scripts, they run from global or set up, how many subdirectories should I have? Where do I store my data? Documentation. There's a place for everything. And one of the reasons that, it's like you always put your keys in the same drawers, you don't always just have to go looking for them. It's kind of the same thing with designing everything as an R package. Where everything lives. So let's get started. As you'll see in this repo, I skipped a slide. The basic workshop agenda is going to be, we're going to cover some basic parts of what makes Shiny applications work, kind of the nuts and bolts. We're going to talk a little bit about kind of beginner Shiny applications and then more advanced Shiny applications. We're going to talk about converting those into a package, and then we're going to cover some basic package components, the documentation, managing dependencies, what to do with your data and other files. And then we're going to go into the kind of unique things about what makes an app package work. And that means launching your application, what to do with those external files that you had in your www folder, and then, of course, how to test your application, because that's, like I said, a huge selling point on why you would convert your Shiny app into a package.
Hey, Mark.
So,
quick question for you. Did you have the slide link by chance?
The slide link, yes. I can drop that into
perfect
the chat.
So they should have Slido in the chat. They've got Posit Cloud, and now you've got the slides. So I think they should be good. And then back to you.
There we go. That should be everybody. Yeah. And actually, yeah, that should be, if you have any, that'll take you to this exact slide. The link to the website stuff is in there too. So the code from this particular application actually comes from this excellent workshop, building web applications with Shiny. Most of the contents of that workshop are kind of like prerequisites for today. So it covers, basic reactivity, your layout, kind of fluid page, and your basic server reactivity. So we're not going to touch too much on reactivity and kind of the reactive diagram or reactive graph. We're going to focus more on the components and files of a package. We will get into reactivity and testing a little bit down the way when we get into testing modules and server tests. So let's get started. The very first branch here in main, this is what would happen if I used the project wizard to just do, project, new project, Shiny app. It gives you this nice boilerplate application, and I can click the run app and I see the Old Faithful Geyser app. This is kind of your standard. Let me give myself a little more room here. This kind of is your standard sidebar layout. It's got some slider input, output as a plot. This is what you get when you create a new Shiny app using the wizard. The files, as you can see, I've added the README. It's not necessary, but a Shiny application can at minimum exist just a single app.r file and a folder. If we're using the RStudio IDE or Posit Workbench, this rproj file kind of serves as a configuration file for what the IDE should be displaying. So this is kind of, I would consider your very basic bare bones Shiny application. As soon as we jump over to the next branch, the next slide, this is what I would consider kind of an intermediate developed Shiny app. And so this has a data file. We're loading the data from this that tutorial I mentioned. So there's some movie review data. We have a utility function that we've written that has some plotting, some ggplot2 plotting, because we wanted to convert that base graphic into a ggplot2 plot. It's written to kind of take any kind of input ID as strings and return a scatter plot. And so if we run this, we see, go ahead and make this big. We see that now we have the movies data, the plot's been updated to ggplot2. We've added in some additional inputs, but this is still all contained within an app.r file, one kind of utility support.r file, and then the data. And so this is still, I would consider a pretty, well developed and designed Shiny application. A lot of times as these things grow in complexity, that root folder just starts, growing in terms of the files, and you start having to source your utility files and load your files manually from that app.r. A more kind of advanced and even more advanced version of this is your next branch, branch 3. And I call this a project app because this is like a fully developed Shiny application project in which we've moved the app.r into modules. So we've actually created an input module and a display module. Our utilities file is still holding our scatter plot function. We have an external resource that we're serving from a www folder. We have a data file here, and the app.r file is just a little bit more complicated because it's calling those modules. We've added an external resource that we're pulling in, and if we run this, also if you notice the dependencies have grown a little bit, we can see that now we have a movies app. It's also using the display mode. So it's actually showing the README and the scripts along with the application. So this is a really kind of, I would say, fully developed and advanced Shiny application project. And this is where a lot of applications get. I think it's really common for people to kind of start with that app.r. It continues to grow. At some point, it just becomes too complex for us to kind of mentally manage in one file. We split it off either into modules or into different components. We source those components either from an R folder or within the app file itself. The reason this is possible is that we have this handy function in Shiny called load support. And what load support does is it'll automatically source the files in the R folder. It sorts them out alphabetically and just, it's the same thing as calling source on all those files. So they're available in your environment. And then it'll serve anything in that www folder. And so if we jump over to the fourth branch, the first file when we are developing an application in which we kind of assume it's going to end up in a package, the first file we really want to pay attention to is the description file. So in the previous application, you saw that it was in showcase mode. This is actually something that's managed from the description. Display mode showcase will make the code display along with the application. You can include other things like the type, the title, the author. For your standard Shiny project, these are standard or these are helpful description fields. These aren't required, but they do configure your application a little bit more, give you just a little bit more control. When we jump over to an R package, so the first thing to kind of tuck away in terms of knowledge is that if you have a Shiny application that you're converting over to an R package, that description file is kind of the first thing that when you try to do any of the package development kind of workflow steps, it's going to look for a description file, and package is going to be the first field it's going to look for. So there are 7 kind of mandatory fields from the Writing R Extensions Manual that every R package should have. That includes a package, the title, the version number. Author and maintainer kind of have this very specific format, and there's actually a utilities function called utils person that'll put it in this format for you. A description of what the package does, and then a license. So these 7 fields are kind of the basic mandatory things that you need to have to start converting your Shiny app project into an R package. These fields, like I said, they're not required for your Shiny app, but when you start converting over, you'll want to create these. There are a couple ways to do this. We'll go through the use this package has a nice function that'll help you create that. There's nothing wrong with editing these files manually. I think that's one of the things that is one of the things that's great about using use this and DevTools is it automates a lot of this. The downside being that you rarely open these files. Some of them you shouldn't open and edit on your own, and you'll see the warning when you do. Some of them it's fine to open and kind of get under the hood and play with them, because you do want to make sure you have a working understanding of what's going on behind the scenes as you're converting over from a Shiny app into an app package. The other file that serves a little bit as a configuration, as I mentioned before, is this R project file. So we encountered this right when we got started, the very first basic application. If you used the Posit Workbench IDE project wizard to create your Shiny app, you automatically end up with an R project file that's just the name of whatever the directory is that this application sits in. And so something about our project files, we really look under the hood with these. They're actually just plain text files that configure the IDE a bit. So when we first created our Shiny application, our project file, if we go back to main, so this our project file, they're a little bit tricky to look at, because obviously if we click on it, it's going to want to open in it's going to want to open a new project because it's telling the IDE what to do. But we can use file edit to open it and see that it's plain text, and you can see that it just has some fields and some values that are telling the IDE, just kind of how we want it to operate. When we jump up to our project branch and we do that, we run the same call, we see a package has some additional fields. So what ends up happening when we activate these project build tools is it reconfigures the IDE a bit to understand that we're not just running an application or developing an R script, we're actually developing a package. And these are some options that we want to make sure and include. These can be, managed either through the IDE itself by going to tools, project option, and build tools, and you'll see these listed. As soon as you click on package, part of the reason I did this manually in the source pane is because I didn't want when you go from project build tools, that'll originally say none, and when you switch this over to package, it'll automatically reinitialize the IDE. So it's a little bit disconcerting if it happens, during a workshop. So I just wanted to warn you. It's the same thing as like running session terminate, and what it's doing is it's just rereading that rproj file, and what that does is it gives you access to the IDE's build tools. These fields in particular are very helpful, and if we want to access that build pane, these top three are required. That bottom one just really kind of helps our workflow. So we'll go ahead and do that. So I'm in the rproj branch right now. Let's go ahead and let's assume that I want to go from developing a Shiny application to a package. If I just manually terminate this, I'll say yes. It's going to reread that rproj file, and now I'm going to see, oh, my utils has been moved. That's too many things open there. And now we see that there's a build pane. Let me go ahead and clear this out. The build pane is great because here we see our build options. We can install the package, we can load everything, we can run tests and check. So this is kind of the first kind of transition from developing your Shiny application to developing a package, is that you're going to interact with not just the source pane and that run app function, that run app button. You're going to have this build pane that you're going to use to monitor, outputs from your documentation, your tests, and it's great because the IDE gives you an output to kind of deal with this development process independent from the console. And it's also handy because we can configure our keyboard shortcuts to make sure that the kind of habits get developed rather quickly. So that's something that I actually want to touch on really quickly here. All right, so we are at 28 minutes. I did want to go ahead and give my first Slido. Bear with me here while I just, let's launch that first. Okay, so I'm going to go ahead and drop this link in the chat just in case somebody didn't get it. But I wanted to ask these two questions. Okay, because then this will kind of determine exactly how much we're going to. Okay, we're looking. Okay, so everybody has a pretty, looks like everybody has a pretty solid understanding. Let that go a bit more, give people time to respond. Give me time to drink some coffee.
Pardon why that's populating. I think somebody was interested in what you had done right before this. They said, could you redo that step? I'm not sure if you saw that, but
oh, what I had to, let's see here. Yes, and to answer that question, we will have a short break. We will have a short break. We'll have multiple. It's probably, we'll be doing polls about every 30 to 45 minutes, and then it's actually broken into 3 sections. So it's at about, I'm trying to make sure that we have a solid 10-minute break at about an hour. But if there's any if there are any questions, or we have to take any tangents, feel free to feel free to drop something in the chat if you want me to either reiterate a step or if you want me to expand on something, because there's obviously a lot of different I want to call them rabbit holes, but a lot of ways to go down on this topic. So the step for, yes, the step for developing, or sorry, for transitioning your branch into, or your package into your app into a package. So what happens when we transitioned from our standard, let's back up a bunch here. So let's go to just your real basic. Gonna bear with me. Let me just make sure we don't have any conflicts with Git here. Okay, so we're gonna have to reset this by going session terminate, because that's gonna it's rereading that R project configuration. I know it might actually be stuck here. Revert, yes. Revert, yes. And now we're going to go back to Movies app. Great. Now I'm going to go. So I backed up a bit to, you notice there's no description file here. So there's no description file. And if I look at the, we're going to go back and take a peek at, there's only what I would consider kind of project fields in our proj file. So these are the standard fields that you get when you just create a new Shiny new Shiny project. And so in here, if I do a session terminate, when it reads this configuration file, you notice the build pane disappears. It's because it doesn't recognize it as a package. But if I jump ahead back to where we were on the project file, and we run the same command in the console, now we see that there are additional fields that have been added for build type, tools, and these are accessible. If I go to tools, I go to project options, these are under build. And so you can kind of see how these link up. So project build tools package is build type package. Use dev tools package functions if available is yes. Here's your R command install options. And this fourth one, this is really just a huge time saver. If you go to configure under your generate documentation with our oxygen, this install and restart isn't initially clicked, but if you click it, you'll see that your documentation is kind of automatically generated when you install your package. So I click OK. It's not going to change anything because these options are already there. But the main point being that if I do a kind of like reinitialize and reread this R project file, it recognizes that I'm wanting to work on a package, and that build pane shows up. So yeah, that kind of is how you get the IDE to recognize that you want to work on a package, not just a Shiny application. And then the description file is really our communication tool with dev tools to make sure that it knows that we're working on a package. So now that we have our metadata, I guess we'll call them metadata files, our project file and our description file, what we'll do is we'll go ahead and test to make sure that we can run the DevTools functions. So let me go back to this split screen. By the way, in the chat, let me know if this split screen is just annoying. I didn't want to be jumping back and forth on Windows a bunch. I hope that my screen is big enough. I can also make one bigger or larger, or bigger or smaller if it's kind of too annoying for everybody. I tried to make the slides big enough to where it would be visible. So one of the best things about the package development workflow in R is that it leverages dev tools and use this. These are great packages that have a lot of the steps that you'll take automated for you. So if you're creating a new package from scratch, if you don't have any code written for your Shiny application, you just want to get started right in that package structure, you can actually just use this create package. And then the path, if you have the path identified and you're kind of working from within the IDE, you want to pass get working directory as opposed to just the kind of quotes and dot for your local path. But this will automatically generate the following files. You'll see the build ignore is very similar to the get ignore. It just tells you what files to ignore when you're building your package, but it automatically generates a description and a namespace to essential files for having in our package, and then in our folder. And then, of course, it's going to generate in our project file that has the fields that we've previously discussed to let it know that you're operating in a package. That way the build pane is available for you. One of the things that I recommend, sorry, I should be using the highlighting when I'm going through these. One of the things that I recommend is there's a fields argument in use description. And there's actually a global variable you can set for this, so you can fill this information out with your email and your name and anything else that you want to include here. But the reason I say to kind of go through this kind of elaborate process that it might look like at first is because if you just run the use this create package, it's not likely that you'll come back and re-edit your description. In fact, if you do a search for any of the boilerplate terms that are automatically added to your description on GitHub, you'll find something like 4,000 packages that
Hi,
have
Sushan, we are good.
under their description, they have what the package does, because they just they got up and running, they started developing code, and then they never went back and edited it. So this actually passes these fields into your description, so that way it's correctly edited with your name, the correct information for the maintainer, the license, and an actual description that fits what the package does. In particular, I wanted to point out there's this utils person function that will automatically put these in the correct format for your description fields. If you're using the IDE and you're in, like we work on Posit Cloud, the enterprise version, so it's just like here, it's in the browser. So there are a couple of additional options that I just, we rarely submit our packages to CRAN, so I don't need that check name function to be run or process to be run. I don't need it to open another session. It can stay in the same session, so I can turn that to false. So these are just things when you're converting your Shiny application over. If you're using use this create package, these are just some additional arguments that I recommend either entering or setting in your options. Okay, so development with DevTools. So a functional R package that contains a Shiny application. And to bear with me, these two files are the two that just inevitably end up changing when you switch over to that package environment. So to be a functioning R package, it needs to have access, in my opinion, needs to have access to this build pane, because otherwise it's kind of like, why are we developing in the IDE in the first place? And then it needs to be able to run these essential DevTools functions, which are they become kind of part of your normal workflow, and that's load, document, and install. So the kind of litmus test is if we run load, we see that it gives us a single output. Down below, it says loading the name of our package. Document is what we'll use to generate the namespace. Document, the output's actually up here in the build pane. And then when we do an install, we can either click this icon or we can run our keyboard shortcut. I'll take a quick tangent here on the keyboard shortcut. So the way I have it configured is my Control or Command Shift L runs load. It'll load everything. And then to install the package, I actually have the same Control or Command Shift B for build, but it's actually calling install. And because we have that configured, that additional configuration when I was in the project build tools. When I click that install and restart, what that does is it combines documentation with installation. So when I run install, when I do my shift control or command B, you'll see it automatically generates documentation. I can also run the documentation independently just by running or holding down shift and control or command and hitting D, and that will just document, not install. So those, I would say that, but the difference between developing a Shiny application and a package is just the habits are different. So typically, if you're developing a Shiny application, you're working in a source pane, either an app.r file or some module. You're going to make some changes to some code. You're either going to save it and then click run, or maybe you have it as an app function, but your habit workflow is, write code, save that code, run the application, review the output. In a package development process, it's somewhat analogous. We just kind of have different habits. It's develop the code in the R folder, load the code, document it, and install the package, and then test the code, and then run the code, check the application. So the reason it's a little bit different is because load all, unlike source, where it puts it in our environment, load all actually is a lot more like running library. So you're actually getting some additional benefits past just source. And keeping your functions or whatever you're developing kind of out of your environment, it actually makes it much easier for development, because it gives you a better understanding of how your package will function or behave when it's installed elsewhere. Like I said, we're always looking for a single kind of output for success, just saying it's loaded. Document does two things. The essential part for the package is it's going to generate the namespace, which is going to manage our dependencies, our imports, and our exports. But it's also going to create the .rd files in our man folder, our manual folder, and those are actually our help files. So when we're documenting our functions using our Oxygen, we're generating them by running this document function from DevTools. So we don't ever have to manually create these. The man folder is automatically generated, and all those files are created on their own. It's great because if you're, I'm going to date myself, but if you've ever had to learn how to write like LaTeX or anything like that, it's a really kind of cryptic syntax, so it's nice to not have to do that. The other benefit is that when you're developing, you can quickly put in some R Oxygen information, do a load in a document, and then you can actually view how that particular function or whatever you documented looks in your help pane, which is always nice because you'll have a better feel for what the user will see on their end. So let's go ahead and then finally, couple points here. The first time that you run document, you might see this note. Again, use this in DevTools. It's very intelligent, so it'll actually note the first time you use it if you haven't already added these fields to your description. So I just wanted to clarify, when it says setting our Oxygen note to 7.2.3, that means the field is getting set in the description. It's not really clear where this is going, but that ends up in your description. And then it tells you that the encoding field is required in this UTF-8, and it's missing. It's not really clear from this output that these are all referring to the description file. So in the description file, we want to make sure that we add the encoding field. Our Oxygen note is automatically added. We have to manually add this encoding UTF-8. Make sure, I've seen it, don't copy this and add it. It needs to go in the description file without quotes. So just to note, the first time you run DevTools document, you might see that output. And that's all that's saying is just that the Oxygen note's been added and that you do need an encoding field. So the future calls, like I said, won't have that. This is a common output that you'll see. It'll write the namespace and then any other RD files that you've been working on. The final step here for install, when we run install, these should look familiar. Those were the fields that we actually had in our project file. This is cleaning the code. It's not installing it on multi-architectures, and it's keeping the source code. It's kind of, I guess, generally what that's referring to. It's going to give us a path that it's installing this to, which is where the location of our installed package will live. And then it's going to install from source. The other important thing is it makes a note here that there are no man pages currently in our package, which we know because we haven't added any R oxygen. So I will take a quick second here to talk about check. If you've jumped over to our packages and maybe done some reading, our packages highly recommends running check. I don't think that's bad advice. If you're planning on submitting your Shiny application to CRAN, then you definitely need to make sure you're passing those CRAN checks. I think for kind of beginner to intermediate Shiny application developers that are working in packages, it's really kind of a necessary. I'm glad that I'm backed up by the advice in mastering Shiny. Hadley actually recommends, it's really not necessary the first time or second time or third time even. So yeah, first we want to make sure that we're just familiar with the loading, documenting, installing. Check again is kind of like down the road if you're submitting it to CRAN, or if you're just really wanting to kind of, I guess, tighten up a lot of your package development. It does some additional things that are great, like it does checks on your namespace dependencies. It looks for any unnecessary or non-standard files or folders in the package structure. It'll let you know about like missing documentation. It's helpful just from a kind of quality control standpoint, but it's by no means necessary to get a working package into production. It should be considered like the gold standard, but it's not, it's not necessary. Okay, take a quick break here. I'm going to ask another poll because we've just accomplished, oh, look at that. I'm scribbling. I don't know what this is.
That's
so how do I get rid of the...
Yeah, I can. I think I can do it.
Yeah, my chicken scratches.
There's Zoom
wow, I
has
didn't
an
realize how often I
annotate.
do it. I'm surprised this thing isn't all marked up.
I think if you, let me see if I can do it real quick. Annotate.
Okay. I'm gonna go ahead and activate this next poll. This is just curious about how many people have developed our packages, kind of what your familiarity is, because the next section, we'll kind of adjust some of that material depending on how everybody's. And let me go ahead and share that link too. By the way, if I'm going way too fast or losing anybody, feel free to tell me to slow down.
I've got a few notes from people that are very new to Shiny. I put a link to Mastering Shiny for them. I do think we originally planned this as like the intermediate advanced Shiny session for people that are beyond creating basic Shiny apps and looking to build testing and unit testing and take things to another level. So if you're on today and you're brand new to Shiny, feel free to send me a question or post in the Zoom chat, and I can send you some links where to get started. But Martin, I think you're doing great. I would just keep focused on the more intermediate advanced user for this session today.
Okay. Well, and I'll make sure I purposefully in the branches, so the application is kind of purposely not very, it's not, this workshop won't cover advanced UI rendering or advanced like data connections or like that. It's still going to be we're going to stick with the same basic structure of a single data file. It's only going to have 2 modules, so you don't have to worry about like complex module communication or complex reactivity. It's going to focus more on the files and development. So I would say even if you are a kind of beginning Shiny application developer, you should still be able to follow along with just our package components. So I would say, there's still some value in sticking around. If it's totally overwhelming, then yeah, I would definitely, the best place to start is that building web applications with Shiny that this workshop is really based on. Okay, another minute or so here, and then we'll jump into our packages. Maybe drink some more coffee. Okay, So from what I see here, we have majority of people are probably more comfortable with Shiny than our packages, which is really what I was expecting. So what we'll do is make sure that we spend a little bit or go into a little bit more detail on our package portion than I did on the Shiny portion. So just to recap, when we were converting our standard Shiny application into an R package, the things that we had to make sure to address that are mandatory are those 7 fields in the description. Those need to be there for your DevTools functions to run. The R project file needs to have those fields that are going to unlock that build pane, which is going to give you access to, seeing the testing outputs, loading. It's going to make your whole workflow much easier. And other than that, the other parts that are just kind of application dependent, if you have additional utility functions, those get moved into the R folder. Your data file is going to be, dealt with kind of down the road in the data section. But this is a bare minimum of what you should be thinking about when you're converting your existing Shiny application into an R package. Just have I checked the description? Is the R project file and is the R project itself configured for the IDE? And can I run these 3 essential DevTools functions? Okay, so hopefully you can go over here. Yes, it didn't mess with those 2. Okay, so let's go into our Oxygen. So documentation is really important, obviously, for our packages when we're using our help pane. That's really the efforts by the package author to make sure that users can understand what the functions in their package do and how they work together. I would say it's even more important for Shiny applications. If you're working with a development team, a lot of times the modules or the application functions, even kind of, I would say, more information is needed because it's not simply run, from an IDE or with a script. It's generating an output that a user will be interacting with. And so we want to include maybe more information about, where this particular function is used in terms of like the module or the portion of the application, the UI. So we're going to cover some of these tags. This is more of a kind of show and tell section. So if I go into my R folder and I start with the utilities function that is rendering my ggplot2 graph, you can see that the first line in your R Oxygen is the title, and the second is the description. You can include these R Oxygen tags. The Oxygen tags look like this. R Oxygen comments. It's just a standard comment in R with a single quote. There is an option if you click at the first opening bracket of your function and you go to code, there's an insert R Oxygen skeleton. And when you click on that, it'll automatically give you these tags. So the good thing is a lot of this can be kind of automatically generated from the IDE. Just a quick note, title and description don't need tags as long as the title is a single line and the description is a single line. As soon as they kind of break into a paragraph, you will need to manually add a title and description. While you're developing, you want to use load and document frequently because that'll generate that RT file that you can preview. So if I'm developing my utility function documentation, a single question mark, and not yet, if I do load and I do documents, then in the console, a single question mark and scatter plot will show me a preview of the documentation. And we can use markdown style syntax to link to external URLs and use like code formatting, which is just kind of nice. You notice I'm using the see also tag because I want to make sure somebody's in my package and trying to figure out what this function is or how it's used. I want to refer them to the actual module function this is called from. So if I click on see also for my scatterplot display module server function. This brings up, let's go ahead and open that R file so we can see, typically when you're building modules, you're actually storing two functions in the same script. So it can be a little bit challenging if you're just, kind of working through the code, knowing exactly where to find everything. So navigating it from the help pane is always nice, because this gives me, how to use this particular module server function. I can see the arguments and their descriptions, the render plot and title from the scatter plot. I have some additional sections in here that I've added with section. So referring to var inputs, which is one of the input arguments, I've just added some additional, information, so that way any developer can see that, oh, I need to refer to the inputs in a reactive context, with the parentheses. And then I also added family, other scatterplot module functions, so that in addition to scatterplot, which we started with, and the server function, I can also check out the UI, and the UI function kind of tells me, just UI functions are pretty basic, but it again links. Family is great because you can group functions that kind of all address a single feature together, and then C also can be kind of your one-to-one link. That's usually the way that when I'm developing our option, that's kind of the way I think about it. I want my help files to kind of serve like a Wikipedia, where you can just click the links to take you to the other Wikipedia page. So I'm trying to give the user the ability to kind of click through the contents of the R folder and see how the application works. Okay, so when we run document, this image is really meant to convey that this is generating the contents of the man folder and the namespace. We don't ever have to manually edit these. It automatically will generate one file per function. So even though we have modules grouped together in an R file, an RD file is generated per function. Okay, so now that we have our documentation, let's jump into some of the dependencies. Okay, so I purposefully, let me make sure. Oh no, I jumped the gun. Sorry, I'm supposed to demonstrate a common error here. So I've written all my documentation. I've been really good about previewing it every time, so I know that everything looks good. I'm satisfied with the way the help files are rendering. And so now I want to run my standalone app function that I've stored my previous app.r file in. So I have a movies app. This just takes the UI and server from my previous app.r and runs Shiny app to generate it from a function as opposed to an app.r file. So when I run movies app, I see this. Could not find function movies app. And so this is our segue into dependencies. So the first question when you're developing your packages in terms of dependencies, I ask myself is, what parts of this package am I like sharing with the users, right? So what functions will a user call when they're using my package? There might be utility functions that only me as a developer needs to know about, and there might be other functions that I'm really envisioning the user is going to be calling. So this is a bummer. We need to make sure that we're exporting those essential functions for the user, especially if we are creating an app package. It's really important that that standalone app function that runs the application is exported. So let's go over to the exports branch. If you're following along, the exports branch, kind of from here on out, one of just the habits you want to get into anyway. It never hurts to run, load, document, and install. So if we run our package development functions, now if I run, the first thing is I notice that if I use my tab completion, I type in movie, I see that I have a movies app exported, and the package itself will give me, the list of the namespaces that are coming out of it. So how do you export a function? It's actually pretty straightforward. You add an export tag from our oxygen just above the function. I usually like to manage my dependencies by just a kind of a practice is as close to the function call itself that I'm developing is where I manage the dependency. So that's where I'm going to do any importing and exporting. That way I just know, as I'm scanning functions to make sure that it's been added, it's always going to be that line right above the function. And especially if I'm using the outline, I can just click on it and then say, did I export this? Or can I go to the checklist? Have I done this yet? So when we ran DevTools document and the export tag was included above our standalone app function, it generated this namespace. I believe these are called directives. Either way, it looks very much like a function. You can see that the namespace automatically exports movies app. In this case, I've also exported the scatter plot, which I will point out in our oxygen skeleton, when you are having the template added, it'll automatically include a tag for examples. I wanted to include an example for scatterplot to show how it works because, obviously we have some named arguments here and it doesn't work like a regular ggplot2 function because it accepts strings. And so for users, I want to make sure that this application or that this example runs. And to get an example to run, you want to make sure that this function is exported. Your examples won't run if it's not. So now that I have this, if I go to my help, if I go back to scatterplot, I can click run examples and I see the output for my documented function. So again, I'll just reiterate, the advice on exports from our packages is, just to choose somewhere between, I would say, being pragmatic and not oversharing, because obviously there's a lot of utility functions that, probably aren't as useful for the user. When it comes to Shiny applications, I think if you're working in a development team where, there's going to be a duplication of processes, across your organization, where if you have a module, for example, that has a database connection and imports a certain set of data, that's something that, another developer or even future you might want to use. So that makes sense to export and document, obviously the standalone app function. But, I think that depending on your particular development environment, exporting the working components of your documented application are always kind of helpful from a development standpoint. It's a personal preference. Okay, imports. This is always an interesting topic because I think that this is it's a challenging it's challenging to get just, I would say, straightforward advice on kind of what is the workflow for managing your imported or add-on packages and functions. When you read through the R extension, writing R extensions manual, the advice on what to import, where to add, the import tags is not very clear. So it's kind of it's understandable why some of this can be kind of confusing. But I've attempted to boil this down to just a couple of workflow tips. So the first thing when you're using an add-on package, by add-on package, I mean anything I didn't write. So this app package, we know automatically will use Shiny, right? Shiny, I didn't write the Shiny package. I'm going to be using it for my app package. So I need to make sure that I have that documented in my imports. ggplot2 is another one. And if you saw the scatterplot function has some additional add-on functions from the rlang package. So the first step is we want to make sure that this package gets added to the imports field in the description. We can do that with use package. After it's added to the imports field in the description, anytime we refer to a function from that package, we want to use what's called a fully qualified variable reference, right? I will also refer to this as just explicit namespacing. And it's that : syntax. So it's package : function. This is a lot more typing. It can be tedious, but the reason to do this, I point out, is that it's obvious to the reader of your code, including you, that you didn't write this function. And so I kind of look at this as like, because you are building your package on the hard work of others, the least I can do is make sure that it's clear I'm not like taking credit for your work by adding the actual package in the colon. There are some exceptions to this. The first exception is if we have a package like Shiny where we are using primarily Shiny functions. This does just become way too tedious, in which case we want to add import. I'm sorry, let me first talk about the other exception. Import from, if there is a specific operator, in our case, we have this data masking operator from our lang. This actually can be explicitly namespaced using the colon syntax. And so in this case, I need to use the R-oxygen tag import from to tell our namespace to go to our lang and pull in this .data operator. The other exception is something like Shiny, where the majority of our code uses Shiny functions. So we can just go ahead and do an import tag, and that will import the entire Shiny package. So we no longer have to explicitly namespace what those are. The places where I would say this gets a little questionable, so something like dplyr or ggplot2. It's unlikely that any developer is going to mistake a ggplot2 function call for like something I wrote, or dplyr, and we all can recognize those. But it is really important to include, and those are very large packages, to just import the entire function or the entire package. So if we're calling it, I would say over it, everybody has their own threshold for frustration. If you're calling an annoying amount of the explicit namespacing, you can add an import tag, but just know that adding that import tag basically makes every function in that package accessible from your package namespace. So hopefully these steps make it clear how to manage your dependencies in terms of the add-on packages. Like I said, the first step is just to make sure it ends up in that imports field. Then you want to refer to it with explicit namespacing and your personal preferences for use import from and import. When we run document in terms of imports, what that will do is it will, again, generate the files for our main folder and the help files, and it'll write the namespace with an import directive. It will not do anything in the description. This is really important. That's why that first step is to use package. This is actually such a point of confusion that there's a section of our packages, second edition, that specifically addresses this, called confusion about imports. So hopefully the workflow that I described means you'll never have any confusion. But this is also just worth reading because it does really describe how the namespace description and code below R really kind of work together in managing your dependencies.
Hey, Mark.
Okay, just to recap on the dependencies, the updates to the namespace are 2 exports and 2 imports, right? We're exporting our standalone app function and our utility function that has a set of examples. We're importing the Shiny package because this is a Shiny app package, and we don't want to have to refer to Shiny functions by explicitly namespacing every time. And we had some special circumstances with our utility function that uses an operator that's not available using the explicit namespacing. So we're going to explicitly use import from. In the description, we now have our imports, our ggplot2, our lang, Shiny theme. So anything that we were calling with library, we used install and library in our standard Shiny application. The way I always look at that is that you kind of want a one-to-one of those library calls to your imports field as you move from a Shiny application to a package. Let me see here. I see the chat's kind of.
Yep, you got a couple questions, Martin, in the chat. I think there was one up above in case you missed it. Can someone let me see.
Okay, yeah, how to open the movies app.rproj. It will open, yes, when you go to I think what you might be asking is how can I look at the fields? So how do you look at the fields in your app? I'm sorry, I'm looking through the chat to make sure I didn't miss anything else. So how do you look at the fields in your rproj file? I know it's a little bit of like an inception problem because it's like the dream within a dream thing. We're in a session that is reading this. So how can I look at this? So if I click on it, it's going to open something else and assume that I'm wanting to interact with the IDE where I just want to look at the plain text fields in it. File.edit. There are two methods. File edit will automatically open the rproj file in the source pane. So you can see it's just a plain text. The other option is in your terminal. If you just want to view the fields, you can do cat. I think I need movies. And that will show you the fields. So that is two methods for checking to see if those fields are in your rproj file. The other, yeah, so can I explain the operator import part a bit more? So yes, I can. In our utility function for scatterplot, by the way, you'll notice I renamed this from utils to the actual name of the function. What we're doing here, I don't want to go too much because this isn't a programming a ggplot2 workshop, but I need to explicitly, this is data masking syntax from Erlang. And what this is doing is saying, allow for a text string from data that's passed, into the function. Because if you go to, if we were using the regular ggplot2 template, we'd initialize the plot with the data frame. And then when we passed our aesthetics in that mapping layer, it would be, AES X equals, and then just the name of the variable without quotes. We need our scatterplot function to allow quotes because the variables are going to be coming into this function as input IDs. And your reactivity is usually, if you're pulling columns from like a UI function, like a select input, they're going to be character strings. And so we want that character string to directly pass into the plotting function. So we're just basically rewriting what would be a normal kind of ggplot2 call to allow for X, Y, and color to accept text string column names. I hope I described that well. And so the dot data allows us to do that. I can't in here the way that I can do ggplot : AES. I can't do rlang : dot data. I have to just call it as it is. So that's why I add import from dot data. Pipes are like another example of this. So any kind of operator that you're getting from another package namespace, you want to make sure that you use import from as opposed to explicit namespace. So hopefully that answers that question. Let me see, what do we have?
I think the one that I saw was, where do you go to insert the oxygen skeleton again? Did you tackle that one, Martin, by chance?
Yeah, sorry, that was a I did that kind of quickly and at the beginning. So in inserting our oxygen skeleton, if I didn't have anything in here, what I would do is I'd place my cursor right at the opening bracket, and then under code, there's an insert our oxygen skeleton. And that will automatically populate with your title, description, parameter, return, and examples. They're great to kind of get started. These other tags, see also import from, export, that's going to be your own kind of personal preference. But the tab completion is your friend when it comes to our oxygen, because you can see just by merely hitting my @ I see all the available options for our oxygen. So let's make sure I'm not saving anything. Okay. So now that we've covered imports, we are going to jump over to data. So this application has a single data file, movies.data, and it was in the root folder. And so to use, sorry, let me back up here. There are three places where we're going to put data in our package. There's data, data raw, and inst external data. We're going to cover the differences in between the three. So data, as you can imagine, it contains your standard package data. So when you're accessing like Star Wars from dplyr, that data file is stored in data, that Star Wars.rda is stored in the data folder. These automatically kind of become part of the package namespace. The way to include these is if they're loaded into your environment, you can pass them to use data, and it'll automatically create this RDA file, which is what I did. I left both of these in there because both of these file types are fine. It'll preferentially, if you're using use this, it'll automatically create the movie's data set as an RDA, but both of them will work. Data raw is actually not a standard R package folder. It's just kind of become standard convention to store any kind of scripts used or intermediate data files used to generate your package data in data raw. If you're following the use this development and you're passing an argument to use data raw, it actually will generate a .r script inside data raw, because it assumes that what you mean by use data raw is I have a script to write that's going to generate a data file. And so because we're using data from another tutorial, we don't have the raw data for it. If we actually go to that tutorial's author, this is what the data files look like from that repo. So this is what it might, that's why I say this is what it might look like, just to give you some examples of the scripts would be something like, pull or scrape the data, maybe combine them into a final data set. And then in here we have some intermediate, maybe the column names aren't formatted the way we see in the kind of finished version, but it's totally common in data raw to store both R scripts and then other kind of intermediate steps for creating your primary data for your package. So the third place that's most common is your inst x data. So this is called the install folder. It's also called the instances folder. I don't know which one is correct. I've never been able to track down which one was the original name. But this folder plays a very special role in packages, and in particular app packages, which we'll see in the future. So inst x data is where you would store data files that you want to be part of your package, but that aren't going to be in a standard R file format. So this is actually like the example that I use a bunch is for a package like Haven or a package like Read Excel. This is where if they were using any examples, because both of those packages, Read Excel deals with interfacing with .xlsx or .xls files. And so the examples is going to have, the examples will have non-standard R file formats, but we want them to run. So we're going to store them in external data. Haven is specifically designed to import multiple file formats. Those examples would be in the external data file. We can access those files from within our package using this. I call this a file path accessor function. I rarely say that out loud, as you can tell by me stumbling over, but what it really does is it gives you access to the location of a particular file in your installed package, which we're going to cover a little bit in the next section, because this actually brings us to our first break. Oh, but never mind. We are going to touch on it here briefly. System file gives you access to the contents of your installed package. This is actually a throwback to, I'm going to date myself again, but there were these awful commercials of like, this is your brain on drugs, and there's a frying egg. But like, what I'm pointing out at is this is your package. This is what we're used to operating with when we look at our source files. We see the description, the namespace, the R folder, any of the files here that we're working with in our files pane in the IDE. When we install our package, when we run DevTools install, this is what is generated. And so it's important to note that while there are similarities, right, the description, namespace, and R and data, there are also differences. One of them being that over here, we can see that there is an inst x data. And when it's installed, the inst prefix or I would say, parent folder is removed. And so what that's referred to in terms of the official documentation is that the contents of the inst subdirectory will be copied recursively to the installation directory. System file is what gives us access to that installation directory. And so when we store anything in inst and we want to refer to it within our package, that's why we call that the package accessor function, is because it's giving you access to this folder tree of your installed package, not the package that you're looking at. So hopefully that clarifies a little bit about what happens with the external data, and also how to access things in that external data location. So if you've ever seen system file used, you know, in a development context, what they're doing is they're referring to a file within the installed version of that package in your package library. We'll touch more on this because this is really handy with app packages, but I want to make sure we're taking time for a break here. I will open another poll. I think actually a couple for people to respond to while on break. These two, oh, I gotta go one at a time. So let me start with biggest challenges. So you feel free to answer these, you know, over the next, we're going to take a break here for 9 minutes, come back at 8:30, but feel free to answer these kind of as you come back at 8:26. I will switch over to the other poll. And if, yeah, I'll hang here. If anybody has a question they want to get caught up or something they want to drop in the chat, feel free to do so. Just make sure you know I'm not making this up. The best place for advice on this actually comes from the R Oxygen 2 documentation. And in here, managing imports and exports. So there's some how-to on exports, but when you get to the imports, I found this to be, you know, really the best. Most R packages is great for kind of the method and the reasoning, but this is, in terms of clear advice, this is more what I found to be helpful. So this is, if you're using just a few functions from another package, we recommend adding imports field to the description and calling those functions with a : explicit syntax. If the repetition of the package name becomes annoying, you can import from and drop the : and that's kind of, I would say that's kind of the threshold I was referring to, whatever annoying is for you. When to use import is a little more clear in our packages, because that's really a case that's specific to if you're using, you know, if you're using a lot of, we don't need to go find it. I can just say, I'll summarize. In our packages, it's the same kind of, if you're using a lot of functions from a particular add-on package, and that's the term they use a lot, then you want to import it, and that saves you from having to explicitly namespace it, but then it also says, you know, that this is also because you are importing all of the functions from that package when you add import, and if you're using a lot of them, it would make sense that you'd want all of them available. So yeah, if you're looking to slim down your performance, so yeah, I mean, all the best packages, and the advice, all of the best packages, if you look at, you know, a lot of the ones that just amaze me, you know, Erlang, which is kind of the standard package that they use as an example, but the things like CLI and the ones that are commonly will encounter during package development, they don't have any imports. They don't import any add-on packages, and that's because they're building everything within the package using base R, using the standard base R syntax that's just automatically loaded with a new R session. So and that's kind of most of us are out here using some combination of base R and add-on packages, from other users. That's kind of the standard workflow. If you're at that level where everything you're developing is base R and it's going to be exported only to, okay. So when possible, do you feel like a base R preferred over other package dependent? Yes. Ideally, in the purest sense, yes, you would write everything in base R. Now, can you do that in an app package? I mean, I wouldn't want to attempt to rewrite Shiny. So this is a trade-off between either performance or the brittleness, because if you have a package that is almost entirely comprised of other package functions, when those fail, your package fails. Now we're automatically kind of like attaching we're attaching our package to Shiny. So yes, we're going to be dependent upon those Shiny functions working. That it's been well tested and stable, so we feel confident with that. Do you want to do this with every single possible add-on, open source development experimental package and function out there? Probably not. You probably want to preferentially try to handle it with base R, but a lot of the better and well-developed and highly used packages, there's a certain amount of efficiency, and if that package is doing kind of the best practices. So again, yeah, the threshold comes from experience, I'm guessing, or is there a good rule of thumb? Yes, the good rule of thumb is if it comes down to time and efficiency. If you are an experienced enough base R programmer to do the work that this add-on package is doing and include it in your code, then I would do that, because you do minimize, again, those possible points of breakage and brittleness. But if you want a very kind of clear division of labor, and you want your app package to handle one particular problem and not handle a bunch of, because most of the time we're using add-ons for utilities, things that, I don't want to rewrite Haven to import SAS files. I don't want to rewrite read Excel to import Excel files. I want to use those packages because those are designed with a specific problem to solve. I can utilize that functionality in my package and use either import from or import. Most of the time I'm not importing the entire package, just that specific function and functionality. So that way I don't have to recreate it. So it does just come down to your level of comfort and experience with the base R. Is going to drive what you want to develop as part of your package. And those utilities that, again, app packages are usually written to create a particular application that serves a particular use case or user specification. So we don't want every app package to rewrite 50 utility functions. I hope that answers that. Hope that answers your question. Let me make sure that where's the other slide? Okay, let me debugging and testing. Good. Yeah, this is just a general question about, no, sorry, wrong one. I'm just curious where everybody learns about new tools and best practices for Shiny development. Just kind of the sources, whether you're online books or blogs, tutorials, talks, internal stuff. Great. And we'll get going here in about a minute or so. Okay, so yeah, blogs, tutorials. All right, so jumping back into app packages. So in this section, we're going to cover kind of the specific components of your new app package, what makes Shiny app packages a little bit different than R packages, and also how we can leverage the architecture of an R package to kind of develop our, sorry, should have drank more coffee on the break. Here we go. Hopefully that is I set up in a way here. Hopefully we can read this. We want to set up our folder structure in our R package, or in our Shiny app package, excuse me, in a way that allows us to load the code, add external resources, and then if we need to, have additional development environments, production environments. So let's get started. We have data. We're going to jump over to the launch app branch. And just like I mentioned before, what we want to do is whenever we switch new branch, if you're following along, we want to do load, document, and build. If you've configured your keyboard shortcuts, I'm doing a Shift Controller Command L for load, then Shift Control Command B for install. And if you set up I'll go through that step one more time. If you go through the package configuration build tools, this generate documentation with our Oxygen, if you click configure, by clicking install and restart, I get to combine document with install. And so that's how I can just hit Shift Command or Control and build, and you see it automatically generates the documentation. So it just saves me one more keystroke. Keystrokes and neurons are really the essential resource here. So launching apps, two common methods for launching Shiny applications. When we were developing a standard Shiny app, we probably had our app.r file open and we saw that run app button at the top. There's also the option, if you've developed out your Shiny application, to have a standalone application function. You maybe called this from an R folder. But these two methods are kind of I would say the personal preference of the developer on whether they're running their application from app.r or they're running it from their standalone app function. R is a functional programming language. So one of the things we want to do when creating a Shiny app package is create a standalone app function to get that documented and in the R folder. So what should go in your standalone app function? These are really, these are things that I tend to include. I've seen variations on this. None of these are required. These are just kind of tips and things that I found to be helpful. One of these is interactive. So this checks to see basically if there's a driver at the helm, to see if this is an interactive environment, and then, kind of describe what to do in non-interactive cases. This is helpful if you are deploying your application from a server somewhere, or you're calling that particular standalone app function, or if there's additional things you want to load in a non-interactive environment. This is kind of helpful, just some control flow for your interactive states. What I usually include is the options list into Shiny app. So Shiny app is the Shiny function that returns a Shiny app object. And there's an options argument that provides a list of key value pairs. So one of the most common is your test mode. Test mode is what allows you to export test values. So sometimes during development, if you're in testing, there's various other options that you want to pass to Shiny app. And you want to make sure when you're writing your standalone app function that those options can be passed the same way that they would in your call to Shiny app. And then just as a bonus, or this is one of those, I'm glad everybody mentioned in the poll. I'm glad everybody has the same problems, it sounds like, that we all have with debugging and testing, and that everybody gets their information on Shiny and development from blog posts, because this was actually covered in a blog post that I believe are at the resources, either on the website or maybe at the end of the talk. The Shiny launch browser option is what controls where the application is launched within the IDE. And so I usually like to give users and developers, and mainly myself, the option of where I'm deploying or where I'm launching this particular application I'm working on. Sometimes I want it to go into the pane where I can view it down in the viewer. Sometimes I want it to go in the window, or if there's something I want to view in the browser, I want to have that control at the standalone app function. or from app.r. You can see that this just runs through some control flow on where to launch. And then what it actually does is, just because I'm a fan of kind of verbose output to the console, it gets the option and then spits it out to the console so I can see what it's currently configured at. So I'm going to go ahead and include that display type function that I've written in my interactive session, and then I'm going to call Shiny app with the options. This is really basic. If there were other non-interactive, behaviors, I can include them here. I kind of kept it simple for this because I just wanted to demonstrate. Most important is just to make sure that your standalone app function does have the ability to include other arguments that will need to be kind of passed down to those nested functions. So let's see how this works in real time. We can close scatterplot. Make sure I'm in. That's right. I'll do it just because I can't remember if I did this. We'll do movies app options list. I'll do test mode equals true, and we'll go run in window. Of course it's gonna, should have known that. Yeah, so it puts it out in the other window. If I'm now, I want to make sure that it's go back to the viewer pane. We'll go ahead and switch it back to pane, and it comes back to the viewer pane. Okay, so that's one option of just the kinds of things that you can include in your standalone app function that gives the developer a little bit more control over where the application is rendering. It's also kind of nice because if you're, like I said, developing a table or a graph and you want to see how it looks in the browser, which is what the user will see, or a lot of times when I'm testing, I want to see the output in the viewer or just in the window. But if I'm really curious about how something looks in terms of the user, I'll switch it over to the browser. Okay, so that handles our standalone app file. Or sorry, our standalone application function. The app.r file, on the other hand, this needs similar workflow, just a little bit, I would say just a little bit more kind of care, because this one had that load support functionality from Shiny. So load support is what was going through, looking at our R folder, sourcing everything, and then serving that www folder. What we want to do is we want to turn that off because we don't want to keep seeing that load support warning. So what I do is I use this nice with R package, which basically lets me temporarily set options that are kind of like used and then consumed. They disappear, so it's not permanently there. And then I included this, just to kind of at the top, you can either use options or get options just to see what your auto load is automatically set to. And what I do is just I kind of do a try catch for some, taking the text stream for the standard error, syncing it to this output. Then because I'm assuming that I'm developing my package well enough for it to be called using library, that's kind of what the try catch is looking for. And then, if not, we use this package load all, which I won't diverge too much here, but when you call DevTools load all, it's actually calling package load all, and that's only because DevTools and use this kind of grew into this giant monolith of a bunch of different processes that are used in package development. And so there was I think in 2018, what they called a conscious uncoupling of DevTools, where the division of labor was separated to individual packages to manage these individual portions. So package load is the smaller, fewer dependencies package that will call our load all function, and it's great because it doesn't, I can explicitly namespace it here and not have to worry about like DevTools and all its dependencies. So you can see from my app.r, I no longer include the call to Shiny app. I include the namespace call to my movies app. function, and then any options, because because this is the application, or assuming this is the file that I have open all the time, and I'm using the app.art to run it, I can highlight everything, pass it over, and it does the same thing as the standalone app function. So you probably noticed my image is gone, right? My shiny logo here has disappeared from my application. And we're going to address that next, because that's one of the other things we have to manage. So there's a lot of times shiny applications require external resources, images, HTML, CSS, or JavaScript that we need to figure out how to include as part of our R package and part of the application. So we are going to jump into that next. The first thing we're going to do is make sure we can get our image back. Okay, so let's close out app.r. I'll go ahead and run it from the standalone app file. So previously, we had an image file that was located in our www folder. And this is a holdover from just regular Shiny development. Anything that you want to reference in the UI and like an image tag, you're going to put in www. The load support function serves www to the application itself, so you can reference those files. In our package environment, we use the inst folder to store external resources, the same way we did with our external data, and we can just move that whole folder over with the image itself. And then what we need to do is we need to explicitly tell Shiny, our UI function, where they can access those files, where they live in terms of their location in our package. And what we don't want to do is we don't want to refer to these files. I don't want to refer to this image file. I want to refer to the installed image file using system file. So this is an example in the movies UI, kind of the master UI layout function for my application. I'm going to add this Shiny add resource path function. I'm going to make this a little bigger. Sorry, the syntax isn't really coming through there. Hopefully it's bigger on your screen. I'm managing two here. But this adds, the prefix is actually the name of the folder, and the directory path argument we are going to use system file for. And so one of the things that's helpful, just for your own kind of like peace of mind of how this works, let me load and build and document again, just to remove any ambiguity. Let's copy where it says it's installing my package. We're going to use, if you're familiar with the FS package, there's this great, as you can tell by the slides, I'm a huge fan of directory trees. This dir tree function spits out a text folder tree. So this is what the source pane looks like. I'm sorry, this is what the source files look like for my standard development. Let's see what happens when I do dir tree on that particular path that it was saying up here it was installing it to. I just need to make sure, because that's going to be the entire library, that's the parent folder, and you make sure I add the name of my package, and I take a look. Okay, so now we can see when I use system file, I'm referring to this www Shiny, not this one. So when we move our external resources into the inst folder, and then we load and document it, they become part of this installed package location. And then these files are what we're accessing with system file. So when we add an external resource or add a resource path, the prefix becomes the name of the folder, right? The prefix, the appended folder, the package, because the package is telling us, where in the library to go look. And then when we want to refer to that particular file, after using our add resource path, we can do it the same way we did in our previous application. We can say, just refer to www Shiny, because the add resource path is saying, hey, this installed folder location needs to be accessed from the UI using this prefix or this subfolder. important note here, this reference is without the inst, right? So we'll never add inst to system file or to our reference system file. I always think of like the system file function basically replaces inst in our source pane. Hopefully that's clear. I really recommend exploring both the contents of your install package, and I just recommend using folder trees to kind of give yourself a mental model of what's happening. So other things that we can do with inst, this is kind of the fun stuff we can do. So this is what's neat about having an application package and this installation architecture, or sorry, this package architecture, is that if I want to, I can include additional resources, and then I can add alternative like layout functions for my application. So if I'm in the middle of development and there's some debate over, no, we want to use the standard fluid page versus like bslib, I can, rather than, I can separate into branches, which is one way to do it. You can separate into branches and create an alternative UI layout. This is assuming that we're not going to change anything in the server. We're just looking at the layout. We can add. Let's go ahead and make sure run is set to pane, just in case it didn't reset there. But let's add a bslib equals true. Now I see the application with a bslib layout. Sorry, this is not doing it justice. Let's go ahead and pop it out. So now we can see it's the exact same application. We're referencing a different image. And the way we can do this is the www resource path is already added in our UI. All I've done is included the alternate layout here in my primary UI function. And this is actually a great way to check additional CSS or styling, is that you can create the layout, because everything's a function. You can create the layout in an alternate function. If we look at the actual code I'm talking about, what I changed in my movies UI, my primary UI function, what I did was I created the standard fluid page. Here's my add resource path, the prefix, and the call to system file. If bslib is false, it's going to do our standard fluid page with my modules. If not, then it's going to use this bslib formatting. And then what's great about this is my UI function, because in my movies app, I've allowed it to basically pass additional arguments. I can just go ahead and add these additional arguments to the UI, and it gives me the ability to control which layout function I'm using and which image I'm referring to in that function. So this is a great example of, I used an image here because I didn't want to dive into CSS and kind of how that's a whole other thing. But the main point here being is that, like, within www anything, whether it was a styling sheet, HTML, or an image, you can have alternate versions of the application layout, still using the same server functionality, and you can add them either as functions or into the main UI function on its own, and that resource path is already there, so you can refer to them. If we want to, we can actually use inst to have completely alternate versions of the application. So if we wanted, if this application, for example, if this was, I've been given the specs for developing a movie review data, whatever bit dashboard, and I'm going back and forth on the sources of data that I want to use. So this is kind of a made up circumstance where maybe I'm going back and forth on whether I want to use, there was a ggplot2 movies data set that was, I think, popular back when the first or second edition of ggplot2 came out. And so it's this nearly identical, but only data from IMDb as opposed to Rotten Tomatoes. So we're just talking about the differences in data sources. So if I have a development version of my application that uses, one connection to a database, and I have, the working version that has another connection, I just want to see maybe the loading speed of one versus the other. This is one way that I can organize my files, where in Inst, what I've actually done is I've created an entirely different kind of app environment. And so I have an image file. I have that alternate data source. It's an FST. FST is an R package and file format for loading. FST is fast, for fast data. And then the app.r, what I've done is just, written some dev versions of these modules. The important thing to note is that in this subfolder within my package, I don't have to rebuild everything from scratch. I did for this demonstration just to kind of show the explicit naming, right? So I prefixed them all with dev, so that way it's clear, because you'll have access to this code, and I didn't want it to be confusing later if you were, assuming that one of these were called from the R folder. But I do have access to anything in my R folder within this inst folder. So that's great if I'm developing and I have some server functionality that, again, I just want to swap out the data and see if see if it loads faster, or see if maybe this is a better use case. And I can run this by just creating an alternate standalone app function and then calling it with a lot of the same parameters and arguments that I did. Let's go ahead and do run equals pane. So yeah, this is loading that ggplot2 data set. I've added, again, maybe I wanted to have a remove missing option. But so here's a development version of an application that's available. And I still have my bslib option, and I still have the standard application all within the same structure. And we can even go farther. I won't actually run this one, but we can even include a production version. So if you want to include like the production version of of an application, sometimes this does this. Let me go ahead and hope this works. My source pane stops responding. So yeah, this is great if you just want to have a dedicated production application. So you can just single app.r file and just whatever arguments you want to include. I only want this to be the production version. So if you decide bslib is the way to go, that would be included here. And this just requires that, wherever you want to call your deployment process from. So like an app.r, if I decide to have this production version of the application, I can refer to it using a slight variation on Shiny app directory, which points to a directory holding an application. So I can refer to my production app folder from this package. And this is, if this is called non-interactively. So basically, if somebody is calling this from a server somewhere and we just want to deploy it, it's going to go to that production app, pull in that bslib argument, and then that's going to be our deployed version. So let's go ahead and recap on this. So again, for just a development version, I have a dev folder. I put an app.r and whatever resources I want in there. Everything under the R folder is accessible in that app. So if I have things that I'm sure about, I know these modules work for importing data and or so on and so forth, I can go ahead and use those in those app files. And then I can just write a standalone app function to launch that. The production version, we can go ahead and have a dedicated production application that just calls our UI and server and whatever arguments we've decided are worthy of production. This one I won't run from there because obviously I don't want to deploy anything from cloud. But there is a production version of it up here that I just spun up, just to kind of show that this is what that does. Okay, so now that we've talked about, oh, there's the poll. Let's go back to, okay. Now that we've talked about what to do with their external resources, let's talk about tests. We're finally into kind of, I would say, the main selling point for, oh, and we're ready for break. That was actually pretty quick. That was a lot of information also. So I wanted to make sure to give everybody a break. And I wanted to make sure before we dive into testing that we get a poll. Let's go ahead and talk about how, if you are developing Shiny applications currently, how you're testing them. Let me drop the link for that in the chat. Yeah, and if there's anything from, I know I went through a lot of information really quick there. I will just say, this is designed for you to have access to all the code and to go, later if you want to download and look through everything. Feel free. The first, I would say, 2 sections are really to get us to testing, because depending on what kinds of applications you build and what the specifications are, you might have use for some of these tools. I wanted to make sure to cover kind of a broad, I guess, a broad set of options for developing your Shiny application, and also a kind of wide set of practices. Whether you're running it from a standalone app function, or if you use app.r, if you do use a lot of CSS or HTML that you include in your application, or you have other kind of data concerns. Hopefully we've covered kind of enough of that with how that works in an app package. Okay, good. So it looks like we are going to talk about testing somewhere between rarely and never, which is actually good. Because a lot of times it is difficult to sell the R package structure if you can develop a very, I would say, complicated and fully featured Shiny application outside of an R package. A hard selling point is like, why am I going through all of this? What is the point of all this? And it is so you can have a tested, well-developed, and fully featured Shiny application. So we will take a little bit of a break here because we have an hour to get through testing, and I want to make sure that we can still, I will hold off on the testing tools. I think we'll just assume that I guess I was wondering if somebody's using a testing tool like for, JavaScript or some other tool that they use for their application, but we will hold off on that. And I want to make sure and give us a little bit of a break before we dive into testing. So we'll reconvene here at about 9:07. Oh, okay. So yeah, am I planning on contrasting this package development approach with a framework? Oof. Yes and no. I can, you specifically mentioned Rhino. Rhino is, I would say it's, I don't want to say everything I learned today is not applicable to Rhino, but in many ways, it isn't, because Rhino doesn't actually convert your Shiny application to a package. It's nothing wrong. There's nothing wrong. I love it. It's it tackles some of the larger issues that kind of exist, with, I would say, maybe the R language, but Rhino is built upon Box, and Box is this other kind of like imagined workflow for managing dependencies and utilizing functions from the R ecosystem. And what Box does is Box has its own language and kind of terminology, which can be confusing, I'd say, if you're developing a Shiny application and you're trying to adopt Rhino, because Box has modules and Shiny applications have modules. But Box modules, what they do is they kind of encapsulate this this workflow we have in R, which is, if I want to use dplyr in a script, I write install packages dplyr, it installs it, library dplyr, and I'm free to go. I can also do install packages dplyr and then not call library, but explicitly namespace anything from dplyr : filter, so on and so forth. Box basically makes all of that explicit. And this is common from other languages. If you've ever come across a Python script, import pandas as PD, import numpys as so on and so forth. A lot of the languages, you actually don't have this, okay, I'm going to use these functions, give me the library, and give me all of it. Box really kind of tries to keep everything very minimal and lightweight, which makes it very fast. But like I said, it is, to everyone who has admitted here that they're new to our package development and intermediate in terms of Shiny, I will share with the group. So I've taken this application, and I was going to say, you kind of dropped an, I don't know whether this is considered an Easter egg or a spoiler, but I do have a website that has this application built in the 3 frameworks, Golem, Rhino, and Leprechaun, which I will share. I'll put up at the end of here. I just need to actually to make sure some of this code is actually there. But it really talks about the differences. I would say the biggest contrast with the frameworks is Golem is probably the most popular that I've encountered from other developers. And what Golem really tried to do is make everything you're learning about in this workshop seamless. So Golem basically took everything that was part of package development and made it very streamlined for a Shiny application. And so it's taken a lot of this packaged working parts and wrapped them in Golem functions, which is great if you're just trying to get an application to production quickly. It still has it has scripts, a managed with scripts. So you'll have a start script, a dev script, and then I believe it's a deploy script. And so that's not to knock on Golem. Golem is great, but I think that if you go to engineering production grade Shiny apps and you're new to package development, the audience there's kind of assumed that you have a intermediate or at least some exposure to the package development process, in which case Golem can be overwhelming very quickly. So I've usually seen people almost resist converting to Golem until they have a really well-developed, complicated Shiny application that's not in the package, and they're kind of forced to, or they have a package management system at their organization that they now kind of have to put this in a package. It's also not very clear if you read Mastering Shiny, the importance of packages is in no way related to the order of chapters, because packages is like chapter 20, and it does mention it's really preferred that it's in a package, but everything before that hasn't addressed how you would do that. So I would say that in terms of frameworks, Rhino is the most unlike these. Golem is, you'll see with Golem, most of the code when you look at Golem, it's wrappers around the use this functions that I've been talking about today. And then Leprechaun is a lightweight Golem. It kind of came out a couple years after Golem did, but it's explicitly meant to kind of be Golem a la carte. So just the things from Golem that you want in your app package without kind of getting the whole framework. So hopefully that answered your question. I won't do like a direct compare and contrast, with Rhino, but I will share that repository that has the same code you see here in three different frameworks, so you can kind of make your own judgment there. I'm going to time to learn one framework over another in terms of design and best prepare app as it becomes more complicated, or how would you suggest the best future proof? So yeah, Jared, I mean, the thing is, I think that the universal kind of, our packages are not going away. Our packages are part of the ecosystem that are going. So I think learning our packages, because if you already know how to develop a Shiny application, just learning how to just get it into an R package will serve you better, because that way you can really decide which framework to use, because the reason I'm hesitant to recommend a framework is because depending on what your application development workflow and needs are, one of them is going to be better than the other. If you have a lot of code and a lot of developers that are coming from other languages, Rhino might be better for you than Golem. So I would say really understanding our package development process and how that works with Shiny will make which framework that you choose much easier kind of down the road. And I mean, I think any one of them, they're all fantastic. So any one of them will work, but they're clearly all not fit for every purpose. So that's why it really comes down to the specifics of the application, your environment and where you're developing it in. I do think that getting access to kind of like if you have access to only CRAN packages versus like the wide world, that'll be a big decider too. But yeah, I can't really. That's why I'm giving this workshop, because I've found a gap exists in Shiny application development and R package development, and I've encountered a lot of very advanced Shiny application developers that resist putting into an R package because they're not as clear on how to do that. And I've also met very developed R package developers that aren't really sure how to fit their Shiny application in there. Do you have an order of learning when it comes to R Shiny versus R packages, like learning one before the other, or would there be a helpful or less confusing? Oof, man, I swear you're not a what are they called? You're not a plant. Yes, I am actually. All of the materials from today are on the final slide in a book that I am putting together. That it is, say, 80% there. So a lot of what you're seeing is in this book that is formatted very much the same way as our. It does. So these chapters are still in development, but they refer to the website that I'm going to show you, point you to. But this text is one place that you can go to. Basically, I've structured it more like our packages than mastering Shiny, in that it starts off with kind of the whole game. If you want to go through building from scratch a Shiny application as a package, this chapter will show you that. I really wasn't gonna. There's a link to this at the final slide, but you asked the question, so shameless plug. There is a resource where you can kind of at least get exposed. This isn't meant to replace our packages or mastering Shiny or Golem. It's just meant to connect the dots between these kind of disparate sources. So we will. Wait a minute. Am I even sharing? Oh, I'm not even sharing my screen. Am I?
No, I'm featuring you because we're recording.
So that whole spiel. Phil, you didn't even interrupt me. You let me do it. There is. That's how I was pointing to this. There is a.
Go ahead and share your screen now if you want.
Oh, it is.
Yeah, I'm not seeing it.
This is sharing on my end. Is it sharing?
Now it's sharing. It looks good. Yeah.
The lag here. Okay. Yeah, let me get to the. I'm sorry. Let me get to the chat. Let me make sure that you have access to what it was I was just rambling about without giving any. There. I do have a Shiny app packages. The book is still being developed, but it is meant to connect. And this is all born of just too many instances of. I tried to jump into Golem. It was like way over my head, and the text assumed that I knew how to develop an R package, and then I know how to build our packages, but I have no idea how to get a Shiny application into them, and kind of how to like manage, the reactivity and how to test it. So this is really meant to kind of connect that packages chapter from mastering Shiny to a lot of the kind of like application best practice stuff from the Golem framework, and then our packages. This really uses a lot of the dependency management, namespace, or oxygen from there. So it's really just meant to kind of be a connecting the dots of all those places. And what I've tried to do is distill information to just what you need to do to get your Shiny application into a package environment and shoot it off into production. So hopefully that's helpful. And yeah, like I said, it does reference a lot of the branches in the code that we're using today. So you'll have access to that code and the book. So anything that I went over too quickly or you want more depth, the book is definitely your best resource for that. Feel free to open a question. I hope so. Yeah, no, and believe me, once your name right, Kinga, you're not alone. Yeah, this book was born out of necessity. It just wasn't really clear in our packages. Our packages, you're reading it and you're thinking, great, but how does this apply to Shiny? And then in mastering Shiny, you're thinking this is all fantastic. I feel like an expert Shiny application developer, but there's like one tiny section about about packages at the very end, and it's a kind of like oh wait, this whole thing is I'm supposed to be doing all this in a package. So this is really meant to kind of connect those two points. Okay, back to our slides. Tests. So far we've covered our package, our oxygen dependencies, what to do with the data, whether to put it in data raw, or the external data, how to launch our app using a standalone app function or an app.r file, and then what to do with those external resources that we had in www. That can include images, CSS, HTML, so on. So kind of the meat of the talk, and we have 45 minutes. I'm hoping it's enough time to get through all the different types of tests. But first, we're going to talk about setting up your test suite for your Shiny app package. And fixtures and helpers are kind of a new addition to the test that package. So we're going to talk about how to use pictures or anything that's like a static data file, any kind of file or value that you want to make sure that is part of that test environment. And then helpers are, in this case, it's like a function that is specific to testing that isn't necessarily part of the application. And then we're going to talk about some of the testing modules for unit tests, and then how to conduct like a system test for your entire application. But most importantly, this is all kind of under the umbrella of a great book I read for behavior-driven development. We'll get to that. So to set up your test suite, use this as a great function, of course, to make this all automated. The 3 that you pass is actually the addition. So test that has been used so much, and it's kind of I think it was like 12,000 our packages rely on test that. So now not only they not only have versions, they have additions. And this is to make sure that the backwards compatibility, it doesn't break any previous versions of test that, and it can still continue to develop in the future. So when you run use test that, the description file adds the test that version. And it's under your suggests field in your description. And then this config test that addition is also added to your description. So not only are we specifying the version, we're also specifying the addition of test that to make sure that the tests run correctly, and that the use this that you're using kind of exists in perpetuity in your package. A new test folder is created with a test that subfolder, and this file called a test runner is created. And we don't ever touch this file. I'm not even going to cover its contents, because most of the time you'll just forget it's there. It doesn't. It's used to make sure your package is called and to run the files, run the test files in your package. How do we create new tests? For every R file in R, we want to create a corresponding test file in our test folder, and we can do that with the use test function. You can manually create and test that, go to new file, but you want to make sure that every test file has a test hyphen prefix to separate it. A lot of times this is just so much faster. If you've been exposed to Golem, I will say one of the things, Golem does have some workflow functions that makes life easier for developing packages. The 2, I will say, add module, I would say add module and the option to add a test. So yeah, most of the time as you're developing your app package, you will want to make sure that it's clear which of your functions in your R folder or which of your files in your R folder contain modules. And Golem has this handy add module, which it automatically appends this prefix from mod at the front of the modules, which makes it really easy for you to identify those files, both using tab completion and when you're running tests. So I recommend adopting, it doesn't have to be mod, but adopting some kind of naming convention to separate your module files and functions from the rest of the code. You'll save yourself a bunch of time, and it'll be easier for you to find them. It's also much easier for other users who come in to separate your module code, because a lot of times as we're breaking the application into separate components and debugging, identifying those modules and separating them from the other code is helpful. All right. When we run our use test for scatterplot, the first thing is it creates the test file and then it'll automatically open it. That test file contains some boilerplate code for a test that test. And in the test, we have a description and then a code argument. The code argument is where we're going to drop our test code. And our test code almost always consists of creating some kind of object, passing it to an expectation that we have, and then comparing it against the known result. So standard kind of unit test is that a unit test, for every corresponding single unit of work, there is a single expected result, and the correspondence between those two things is whether the test passes or fails. Kind of unit is, of course, we're assuming the atomic version of unit, like this, in terms of division to labor, this function does this thing, and this thing is what we're putting in expected. A bit about running tests. So in the build pane, I'll get back to my view that I hope is not too terrible. Look at, I waited too long. It left me. I guess I left it. Test will test every test in the package in the build pane. The icon will test every test you have written in the test that folder. So it's always just a great tool for, I'm not the first one to mention this, those of us that are working on multiple applications and writing tests and trying to keep our code tested and at least working. A lot of times the first thing that I'll do when I open an application that I haven't worked on in a while is I'll obviously do a load and install, and then I will just run test, because what that will do is it'll automatically tell me the last thing I tested. And I usually write my tests in such that, like, when I'm going to write a test that fails where I left off in this package. Because what that does, when I hit test, I can then go, okay, so I'm testing this particular module or function. That must be where I left off in terms of, development. And it's a great kind of check to make sure, because a lot of times, if you're like me, you are working on a project and, some other, I don't call them distractions, something else comes across, you work on it for a couple hours or even a couple of weeks or whatever, and then you come back to this project and you have no idea. There's some code, there are some tests, there's some data, some things seem to be working. I don't know exactly where I left off. This is a great method for you to make sure that you know where you left off in terms of development, because obviously the things that have been tested, you don't have to worry about. Okay, so let's talk now about the keyboard shortcuts. This gets back to what to name your files. So as I just said, test is going to test the entire suite of tests that we've written. A lot of times, though, we just want to test a single test file. And so to do that, we need to go to our tools, modify keyboard shortcuts. And if you search for test, there's a run test file, which I've actually bound to just Control or Command T. So if I'm in a test file and it's open, if I run my Control or Command T, it's only going to run the tests that are in that file. And I want to also check the test coverage for that particular file. We'll get to test coverage and what that is, but these two are handy from a developer standpoint, because a lot of times I don't need to run through all of the tests for the package every time I'm developing. A lot of times I just want that single file and the coverage for that single file. So we'll make sure that those are applied. And now we're going to talk a little bit about, this is actually, we will need less code, more slides for this, application specifications. So I've always had the experience of, when I was just a Shiny application, I won't say just, but when that was my dedicated role was a Shiny application developer. A lot of times I would meet with a stakeholder or a user, and they would have an idea for what they wanted this application to do, the data that they were expecting it to have, and kind of the exploration techniques or the modeling or whatever they wanted to implement, and kind of what they wanted it to look like. This is where you kind of do your initial meetings, where you do a wireframe. But you capture some language that really is the needs and expectations of the stakeholder end user. From there, I would go to either my own notes or the code, or a lot of times in a specs file, or however I wanted to document this. If it's like a client I'm working on a scope of work, the features then would describe these high-level capabilities of the application. The language for the features is still, it's not super technical because this is still a communication tool between me and the user. So a feature describes this kind of high-level capabilities of the application to make sure that a feature is satisfying a user need. Functional requirements are really where those user specifications, those user needs touch code. So a functional requirement is a testable specific behavior. In Shiny world is inputs, outputs. It's what we're rendering. It's the data we're loading. But those feature requirements are kind of mapped all the way back up to they're satisfying a specific user specification, which is what they initially wanted or needed. So I've kind of included this language because this really comes into play when you're testing. Like I said, the excellent book, which I'll refer to at the end, this behavior-driven development in action, talks about how a lot of the best development and testing practices are kind of born of regular communication between users and developers and stakeholders, because a lot of what we're testing, we want to make sure that we're not writing tests or developing code that isn't directly tied to a user specification or user need. So we're not designing the application we think they want to have. We're designing the application that they've requested, and we're writing code that we're more likely to not use, or that isn't gonna satisfy something that the user or stakeholder hasn't explicitly asked for. So a traceability matrix is a table that really kind of maps those initial user specifications into the features that we've kind of described, the capabilities, and then the requirements or functional requirements, where I want to say rubber hits the road, but it's where the user specification touches code, and then the tests that are used to verify that. So this is an example of like a table to do this. I recommend the only thing that's in our current, let me get this a little bit bigger. That's in our current Git branch. So we're in test specs. So I've added vignettes, test specs. And I have to say, now this is not something I would have recommended a couple of years back, because if you've ever had to make a markdown table, it is painful. But we have this wonderful visual mode in our vignettes for our markdown, and it makes creating a traceability matrix so much easier, because we can actually meet with a client. We can talk about whether they sent us slides first, or we're just having a kind of focus group type conversation. We try to capture in their language what those user specifications are. We convert that into kind of high level feature requirements, features, also called feature requirements. Sometimes you will encounter these terms are treated as interchangeable, but they're really not. A feature is still a kind of high level description of a capability, and its tool, or it's used as a tool to communicate that back to the user or stakeholder. The functional requirements are really kind of the technical developer only language that we're implementing the features that were kind of born from the specifications. So we can put all of this in a vignette. This shouldn't be the only place it exists. If you're used to, like an agile type, environment, then you're gonna, maybe use Azure DevOps has places to store this kind of stuff. I usually have at least a draft of it in here, because if I'm using the IDE, and I know my other developers, I want to at least know that they have some reference of, what we've discussed with the stakeholders, what we have in the applications in terms of, the specifications, and broadly what the features are. And I think like I said, the visual mode makes it much easier to work in Markdown. Vignettes are a great place to store any kind of anything like this, because they're automatically part of your package. They get rendered and built automatically with every install. In fact, the great thing about having a vignette that has to build and install is that if you have code that doesn't run in your vignettes, they won't build. So it is kind of a little sandbox for developing any kind of like test code or anything like that. So I highly recommend having vignettes for not just how to use your package, but when you meet with stakeholders, vignettes are a great way for you to kind of communicate or capture the communication to make sure it kind of gets carried along with the package. It doesn't have to be part of like the rendered package down site, but as an internal development document, they're fantastic. So now that we have our specs, let's talk about some actual tests. All right. We don't need the vignette anymore. Don't need this. We're going to stick with just the test files and the functions. Okay. So fixtures. Before we open this up and look at the actual test that has two, I would say, new-ish, well, depending on how you're defining new, behavior-driven development functions. And the reason that I find these incredibly helpful is that, as I said, I read this great book that talked about using these specific syntax and language for writing out feature files, which are really, it's a combination of writing a feature and a scenario. And the great thing about these is it's written in plain language. It's meant for anybody, either the user or the stakeholder, really anybody, to pick up a tester to come up and read these feature files and understand both what the user is expecting from their standpoint, kind of the background of why this feature exists. It also gives you, in the scenario, it gives you very clear steps or actions for what we're testing in the test server test. So as an example, I'm gonna give some examples of these, and there's a lot of ways to write these, but there's a lot of content to put in these, but only a couple ways to write them, which is what makes them great. So a feature in BDD, in behavior-driven development terminology, is the high-level description of an application capability. The background is steps or pre-existing conditions, the kind of like the world as it is before the test is conducted. Given is just one of those keywords that we use to give context for those preconditions for the scenario, and then the scenario itself is a concrete example that illustrates the feature of the application. And so this is all very abstract. I know this is all very, and it's more terminology than you probably want to deal with at the end of a 3-hour workshop, but I'm going to give you some examples of how this looks if you're using teststat and teststat's BDD functions. So we want to describe a feature and background to be included in a nested teststat describe block. And so teststat has a describe function, and the great thing about them is that it just has description code. And so if I'm using these functions, there's a lot of ways to do this. I can have a single describe, but if I want to separate the high level capability and then describe that, and the way to think about this is if I have my vignette open, or I'm talking to my, it's in a set of slides or it's in an email, I want to say, okay, so this feature, this particular capability, it exists, kind of given this initial background, given these conditions of where the data are coming from, given these conditions of, who the users are going to be, whatever it is, I can nest the describe functions in a way that allows me as a tester to say, okay, I can read through this and it can set the stage for the test that I'm about to view. This is, most of the time when you're writing test that test, what you get is that text string that says multiplication works. And that is great for, a developer who knows. By the way, another great thing to do is go to GitHub and search how many tests still include multiplication works. And that's not what they're testing. That's what's great about having these discussions with your stakeholders and actually writing out these behavior-driven development functions, is that you will actually have context for the tests in the test file, not just for you, the developer, but when you come back and you're talking to your team, or your team is off testing your code, or maybe you're testing it and they're developing it. This gives you the context for, hey, this is that particular feature that the users requested. This is the background that you need to know for, what the context is for that test. And then this is the test. So it's just a nice way to kind of provide these additional background and feature descriptions that gives both the tester and developer more information, but also it makes sure we're not writing code for tests that don't need to be done. Let's see here. I was supposed to be clicking through that as I was talking. Okay, so we describe a feature, and then in a scenario, we write a test for it. So the complement to describe is it. And you can see describe it. And so it's describe the feature, test it. Because the it function from test that is identical to test that, which is the test function. So in standard test that development, test that is the only thing that's generated when you do use test. You get a test file. There's a single call to test that. It says multiplication works, and there are expectations. If you adopt the behavior-driven development functions, you would have a describe function that would describe some feature, some higher level specification or context. And then inside the describe function, you would test that particular feature. And it's nice because if we're using the kind of standard behavior-driven development syntax, we have a feature that gives us the background of the capability and the background of the kind of pre-existing conditions. And then for the scenario, we have this very particular language of, in this scenario of a concrete example that illustrates the feature that this is part of, we have a given, when, and then. And let's see how this works if we're using a test fixture. So like I said, a test fixture is anything used to create a repeatable test condition, data, file paths, functions, etc. They are stored in this fixtures folder underneath test that. So in here, we can see our fixtures. By the way, the name fixtures is not required. In our packages, that's the folder name they use, and I didn't want to confuse anybody that was later looking there, but you can use any name if you want to abbreviate that to fixed or whatever. But the folder that you're calling from your fixtures beneath test that is going to be this is where they're going to be able to be added to your tests, and then we want to make sure that they're removed or destroyed after, because we don't want lingering fixtures around in our environment for other tests. So what does this look like in terms of a BDD description and functions? Okay, so we have this alternate version of the ggplot2 movies data that we want to verify can work with our scatter plot function. And all we want to do is have this alternate data set. We want to make sure that if we're passing it to our custom ggplot2 function, that the values that we're mapping into the function are the values that are in the plot. So the feature, scatter plot visualization, as a film data analyst, I want to explore movie review data from IMDb so that I can analyze relationships between movie metrics. So this, as you can tell, is written from the user, right? There wasn't any mention of the columns or rows. There's no mention of the API that it's coming from. It's just as a user, I want so that and most of the times, I would say this is, in kind of business language, the feature describes the value that the application is bringing, right? As a user, I want to do this so that I can add value, improve decision-making, and in some business sense, that is what the feature is. It can be tracked kind of back to the value that that particular application adds. The background is anything else that we need to describe in terms of the context, right? So given I have data with IMDb movie reviews, and the data contains continuous variables like rating, and the data contains categorical variables like MPAA, you can see the background is a conversation back and forth, right, with the user stakeholder to give the developer some context of, okay, so I understand you want to have this particular dashboard to add value. I need some context for, what kinds of metrics you want to see in your dashboard. So again, these are very specific language with the BDD. If you're following this kind of syntax, it's all given, when, then, and then the feature is, as a user, I want action, so that outcome. Okay. We're going to illustrate this scenario that we have with our test fixture in this test. So create a scatter plot. Given that I've launched the movie review exploration app, when the plot renders, the plot on the x-axis should represent, this field. We're telling it exactly what values, when we pass them into our scatter plot function, because remember, this is a test for scatter plot, what we're expecting the points in the graph to be. There's a given when, and then all of the thens. So given when, then, you can see I just add a bunch of ands for the outcomes that we're expecting. The test fixture data, most of the time when you're the recommendation from our packages, if you're creating a data set or a static data or a static test fixture, the test fixture has a script that creates it called make. So this is the code used to create or tidy movies data, and that basically gives us a kind of, I would say, data provenance for your test fixture. Still has the source of where it came from, but you usually want to make sure that the naming convention is pretty clear. I think they use make, they might use in our package, but just as long as you can see the output file has a corresponding make file or some other naming convention, so it's clear what the corresponding file and output is. Okay. What this looks like in terms of the test. Inside the test for a fixture, it actually works a lot like we did for the system test. So you can see what I've done is I've included a nested describe chunk here, and this is, maybe I'm pulling the language directly, like I said, from a vignette or a set of slides, but I'm going to describe the feature and its capabilities. I'm going to give some background and context for any pre-existing conditions, and then I'm going to very explicitly in plain language describe a scenario with given this action, given this background, when this action happens, then these are the outcomes. That's really straightforward in the test that it block. And assuming I have run load and build, I'm sure I did. If I have this test file open, I can just do a Control-NT, and we see the test passes. Great. So there is testing. I know it seems strange that we're putting all this work in for just this simple output, but you really will learn to really love seeing that little pass turn green. So you can see what this test does is it takes some inputs, right? We're simulating some user inputs in a list. We are loading our test fixture. And so there's this test path function from the test that package, which works a lot like system file, but we can pass it the name of the fixtures folder. And that, oh yeah, keyboard shortcut cheat sheet. I know I was actually going to say, I should have put those at the front of our site or let you know, but people do have their own preferences with keyboard shortcuts. I know I've encountered people who do it differently. So I don't want to steer you toward, you might have a better way than I do. But what we want to do is we want to use that test path to read the RDS file. So this is pulling this file directly into our test. We're passing that, that alternate tidy ggplot2 movies data into the scatter plot. We're referencing the X, Y, Z, and alpha arguments. And then we're just making sure that the output is a ggplot2 object with expect true. So that if that evaluates to true, then we get a passing test. So that was an example of using a text fixture. We had some alternate static data. The reason that I chose to put that in a test fixture, by the way, and not a test helper, is that it would take a long time to put all of the code that is here, that is, creating this alternate version of ggplot2 movies. We don't want to put this into our test, right? So here is where our test begins. Test that. By the way, this can be just, if you're used to the older, these are identical, right? So test that and test that. They're doing the same thing. So you can see I swapped it out and I run tests. It's the same thing. But where this used to say multiplication works, we've now outlined a full scenario, and we preceded it with some context about the feature and the background. But what we're trying to do, there was a blog post actually, I think, either on Tidyverse or on the Posit blog, about one of the big improvements with the latest release of test that is that we're trying to move any out of scope test code. So we want to minimize the amount of code that exists outside that test. And so what we're trying to do with the BDD functions is we're trying to give background and context of a feature that isn't code. This is just for the developer and for the tester, so that we can reduce the amount of code that we need inside the test to get the test to run. And so in this particular example, we want to make sure that we can test this alternate test data by adding it as a fixture, and then we want to load that fixture into the test, run the test, check to see that the output meets our expectations, and then kind of wash our hands and be done with it, right? So there's no more lingering code outside of the test environment. So what did I do? Oh, yeah, I swapped that out. Let me go ahead and revert that back to previous and we will go over to helpers. So now that we've talked about helpers, or talked about tests, or I want to move a little bit quicker because I do want to get to some of the debugging and other testing topics. So helpers are very much like fixtures. They're just tools that'll help us get the testing work done. I have some examples here that I wanted to point out. They can go in. This is kind of a protected prefix helper. So underneath tests and test that, if you have a helper file, it is automatically loaded with load all, and you don't have to worry about. So the functions here will automatically be included in your test when you run load all. So one example is in the previous test. I had this this inputs list that I made, right? So one example would be I could just write a function called var inputs, put that in helper, and that way I don't have to like manually build this list, right? I can just call var inputs. This does have the added benefit of, if you write a var inputs function, you can actually like refer to the inputs for the scatter plot the same way you would in Shiny. So referring to var inputs, the function here with X, Y, that's almost identical to what we would see in a module reference, right? Because var inputs, again, like the inputs are coming from another module. They're being, collected kind of like from the UI, passed into this scatterplot display module. So this syntax is very familiar and easy. I was going to say it makes life easier for the developer because I don't need to like rewrite my scatterplot code, right? I can just basically take the same thing I'm doing over in the module and put in the test and call it good. The reason I actually recommend not doing that is because for anyone else who comes into the contact with this, it's really not clear where that comes from, unless they go into your helpers file, or they just, they happen to know that you've written a helper for that. So there is some violation of our dry principle when we're writing tests. And I use this example to kind of like point out that if the code is helping explain what the behaviors is that's being tested, we want to keep that in our test. So like the previous test, it was explicitly testing, values and a test, values from a specific test fixture. So we didn't want to abstract that away to a function. We want the test itself to kind of, be self-explanatory. So we don't want to abstract that away. It also makes it hard to debug the test when it inevitably fails, because we want to write tests that are easy to debug when they fail, because we assume after writing them, we're only going to be interacting with them at failure. Yeah, that's, but I put in text what I just said. But to make life easier, we can write these little handy, like I have make inputs. So if I load everything, if I want to use the make ggplot2 inputs, if I do some combination of glue or glue claps, by merely passing this, I do get a nice printed, this to me, if we're trying to save keystrokes in neurons, I can make a helper function that gives me the values that make it explicit just as easily as just copying and pasting there. This still saves me time, so I'm not rebuilding the list manually. It's putting it into the console, making it easy for me to kind of make that copy and paste workflow that's explicit just a little bit less painful. So that's just one example of, instead of abstracting away something to a function, which is harder for the future developer or tester, you can make helpers that are really help facilitate, this non-dry kind of testing workflow. Another example that I will include for a testing utility function that I use quite a bit is any kind of logging. So I'm a big fan of verbose output in my test. This pass looks great, but I would really like to see more. So I have a utility function for testing that just allows me to kind of provide even more information at the start and end of a test that comes out in the output. So when I'm iterating and building my tests, I can see the test start, test end, and any information that I want to add about, either the functional requirement, the data that's being loaded, that kind of stuff. So, yeah, we'll do I already did hope, but it never hurts to do it again. We'll build it again. Probably need to build it. I'm just so used to doing both. But if we open our test file here and we run tests, we see that by adding, the helper, I've added some information about, this is maybe the test number, and then, but this is actually testing, this is the fixtures data, and that one's testing the standard data, right? And this is just an example of a helper function that me as a developer, I want more verbose output. So I want to, maybe include some kind of logging. It also gives like the time that, if I have a rather long snapshot or something, it'll print that out also. So, good point that I almost glossed over. If you are using a common or a test utility so often that you want to make sure it's part of the package, you can also just have a test that or test utils and just include that as part of the package. Okay, 8 minutes to get through testing modules. This was the important part. System tests are great. Whenever user base, I will answer your question. Testing copy and paste. I will answer your question. Let me go ahead and get through this testing modules. And then if anybody wants to, stay a little bit after, I will go through system tests. So testing modules. So one of the things that inevitably comes up is if I'm testing a specific module behavior, right, that's communicating or transferring values like we have here, how do I do this without basically, doing either a full system test or using Shiny Test 2? What method do I have available to me to really get at the reactivity or the communication between the modules? Because what I really want to know is, can the user pass inputs to the variable input module? Can those inputs come out of the variable input module? Can they be passed into the scatterplot display module? Right. That's really, in terms of features and scenarios, that's That's kind of the plain language version of what I want to do. And so what type of scenarios call for a snapshot or module test? Given the application is loaded, the initial scatter plot should show a certain set of predetermined columns and graph aesthetics, right? So first want to make sure the thing loads correctly. When it's loaded and I change something, do those changes, are they reflected in the application? So these are these are scenarios that directly refer to the communication between two modules. So we have a variable inputs module and we have a graph display module. And the scenario that's described right here is when the application loads, are the initial values in the UI and basically creating the plot object. And then if there are changes, does that also result in changes downstream in terms of the display module and the graph object? So let's talk about how we can do this without having to call on Shiny Test 2 and doing a full system test. So if we use Shiny's test server function, and test server works well with unit tests and the test that architecture, and we pass in the input server function, and we say, set these inputs from the UI. So if we look at the actual, I'm going to distract a bit too much with these other files, but if we look at our modvar input module and we go to the actual values, so we can see audience score is the Y, right? So we pull the actual values that are going to be displayed in the UI based on our design. If we set those inputs and then we do an expect equal from session returned to those same values, that tells us that in our, as I just closed that, I need to make sure. So remember, this is just an input module. All the server variable input module is doing is returning those inputs from the UI. So it only has one purpose, that's take everything that's being loaded in the UI, send it out as reactives. So we have a return reactive list. So when we test that, we say, given those inputs that we supplied in the UI, when we return it, are they identical? That test. That test, I won't go through all of the descriptions. You can feel free to dig through the code and see, but we can see that test pass. And you can see my logger is more helpful now than ever. I just want my initial inputs returned. Okay, great. So feeling good about that. But the tricky part is, okay, but how can I be sure, because they're reactives, they're coming back. How can I test to see if the reactive values, i.e. the selected vars here in my main server function, how can I make sure that this is reactive when it's passed into the display? So if I try to do the same, this test server, if I try to supply the var inputs, by the way, when I'm referring to var inputs, that is the argument in the scatterplot display module that is basically collecting those inputs from the UI. So how do I make sure that these are passed? Well, if I try to just use the args list from test server, the additional arguments in your modules, and I supply a list like I did before, I get this error. It says error in var inputs, could not find function var inputs, right? I'm not supplying it here as a function, but it is taking the return values as a function. And so what I can do, this is a handy trick that's not in the test server documentation, and it's a great way to get unit tests to check some of the module communication without having to go all the way to Shiny Test 2, is that you can actually wrap the values in reactive in the args list of test server. So it's subtle here, but what I've done is I've supplied Shiny reactive to these lists, or to this list of values that I'm passing into the test. So into the test itself, I'm sending a set of reactive values that I can then check using the same object that I would use in the module to render the plot. So inside the display module, I create this reactive object called inputs, and that is actually the object that's used. It's a list that's used to create the scatter plot. So I can use the same non-reactive values, right, that I passed in here reactively. And why is that? How does that work? It's because inside app server here, or movie server, we can see that we are calling selected vars, which is the output from our input, our variable input module. Now we know that that's a reactive list. It returns a reactive list. Because there are no parentheses on selected vars, what we're actually calling is the method. So if we're using the debugger and we're the browser, if we look at the difference between selected vars with and without the parentheses, we see that without the parentheses, it's the method. It's literally the reactive list call that's being passed into our display, our scatter plot display server function. And so when we're writing the test, we need to make sure we simulate that behavior and not pass the actual values, which is why when we ran the test, it wasn't just these values, it needed to be wrapped in reactive. And so we can simulate reactivity by passing in reactive values from one module to another. And the great thing about this is we can test alternative inputs. So if we don't just want to check the initial values, we actually want to see, okay, so what happens when they pass in, IMDb number of votes and genre as opposed to the previous values. We can pass those in and check those. It's 10 o'clock. I want to leave on this note, and then I will continue. But the testing modules and kind of testing outputs, the important thing from a development standpoint is when you're looking at kind of testing efficiency. If you're writing utility functions that handle business logic, that create models or run calculations or anything like that, database connections, those all need unit tests. They all need to be working. I mean, there's kind of no shortcut around that. That all needs to be working. If you're testing modules and application behavior, really, if you're testing user specifications, the biggest thing to think about is there's this great portion from the documentation. The goal for your test should be to ask, is the code that I wrote producing the plot I want, or abstract that to the thing I want? There are two components to get that question. Does the plot generate without producing an error? And is the plot visually correct? And test servers are great for assessing the first component. So the reason I included this is because there's a whole bunch of behaviors that modules do that don't require a full kind of Shiny test to, basically a fully recorded system test. There are a whole bunch of things that we can do with a module test that we can test to make sure that it renders in the application without an error. And so if you noticed, I used this expect equal is ggplot. And it's not that I only care about it being a ggplot object. Obviously, I care about the visual correctness. But when I'm doing my test for the modules, what I want to focus on is that it's rendering the expected type or class of the output that the render function is going to use. And I don't need to rewrite the test for the render function. If I'm generating a ggplot2 object, the render function is going to render it. I can later use a snapshot or just a communication, between me and the stakeholder to decide, hey, is this visually correct? I don't need to kind of burden down a whole bunch of snapshot tests. What I really care about with the module is producing the correct object that will be passed to the render function. I can trust that the render function is written well enough to render that plot object. I don't need to spend a bunch of time writing snapshots and reviewing snapshots. So there's just a little bit of kind of efficiency and approach in terms of testing your module server functions. Make sure that you're actually testing does this output generate without producing an error, and not is this visually correct, which is farther down the road for like a system test. The system test, the final slides here that we'll talk about, we'll get through those, but this was really the place I wanted to get to today, because the modules are just functions in an R package. They're a little bit different because we store them in the same file, but when we're talking about developing tests for them, I like to take a unit testing approach to modules, because it lets me develop, again, a behavior-driven development kind of test of this feature that is being addressed by this module, because a lot of times I really think the best mental map for a module is that you have a module per feature, right? I have a plot output, I have a UI input, that collectively, maybe that is two modules for one feature, but I've found that at least kind of starting with a feature per module approach, I know that there is some expectation that that's some expectation from a user or need that I've translated into a capability that might have a couple of utility functions and other things that, are the functional requirements that support it. But when it comes to developing the test for the module, I know that I have a scenario in mind that user is going to be clicking through on the application that I can then put into the test. So that way it's very clear in advance what this is meant to satisfy in terms of need and what has to be written in terms of test. So let me jump ahead to in closing, because I want to make sure I get those resources out, but then I will stay a little bit and go after system tests. So yeah, just to recap, Shiny app packages. What we've covered today is that there are some specific metadata files that we need to make sure we include in Shiny app packages that include the description and our project files and fields. We want to make sure that we're addressing all of the documentation with RxyGen and that we manage our dependencies. We talked about where to store data. We talked about the differences between kind of launching your application between an app.r file and a standalone app function. How to manage external resources in your www folder that become part of an app package. Finally, we talked a little bit about tests. We didn't get to as much as I wish on the modules, but we talked about how to use fixtures and helpers in your test suite. And unfortunately, we kind of came up with a donut on the system test, but I will stay after for a bit here for anybody who can stick around for the system tests. Okay, let me go ahead. I just want to make sure that ended for a nice clean break for the recording. So, okay, so where I left off with modules. So now that we've tested the inputs and outputs, both from our variable input from the UI and the reactive input that's created, I'm sure you're probably happier looking at the code for this. So this, as we know, is a reactive that's coming out of the UI. But it's assigned here as a method, so it's not the actual values. This is what we addressed by wrapping the values in reactive. So we're passing a reactive list into our test for the scatter plot display server, and then we're just verifying the downstream output is the same as what we're expecting inside. It'll probably help a bunch. I keep on referring to this inputs. As you can see how the display scatter plot display server works is that it truly just collects those variable inputs. It creates a single object called inputs, and then that is what is used to build our plot. So when I'm testing this object inputs, I'm making sure that the values inside the module match the values that I passed outside the module. So this is a way that I can I can approximate module communication, right? Because obviously with test server, I can only pass one function at a time, but I just verified with the UI that these are in fact being returned, right? I have this wonderful session returned. So I've just verified that returned values are working. And now that I've gone through and created this reactive list of values that are passed in and confirmed inside the module that inputs is there, I'm fairly confident that the values are at least being passed from my variable input module into my scatterplot display module. And this is without having to, the good thing about this too is that system tests take a while. If you're running Shiny Test 2, they're slower, they're harder to set up. Well, Shiny Test 2 does a great job of making it easy to record a test, but I would say that they tend to take longer to run. So what we want is a relatively quick way of making sure that our modules are communicating. So this is just a method that I've found that works really well when I have modules that are passing values from one to another. I will quickly write the tests that describe that scenario. Basically, user selects these values, display shows these values, and then pass the list from the output as a reactive to the next test. So, that's why you can't work on two different operating systems, because you will inevitably hit command when you're meant to hit control. There we go. So I'm testing the active file. If I go to my display, I'm going to test this file, and good news. Okay, so we have a passing test for the module communication between one and the other. If I want to check the test coverage for the active file, I get a 71% because I don't have the UI tested right now. If you want, you can always do a snapshot test for those. A lot of times UI tests are better for system tests because we want to check it holistically. It's difficult to test a module UI portion in an isolated environment, but we can see we are passing it through kind of the meat of this 71% is good enough for me, because I know that UI test or the system test will handle the UI. This is enough for me to feel confident about my my module communication here. So now that we have our modules tested, let me go back to that. That was a terrible split view. Does anybody want me to cover again how this works? Because I have had people ask questions about the difference between returning an object with parentheses and without parentheses, and the browser is really your friend here, because you can see with the browser inside a module what the difference is. The method is passed if it's a reactive object that's returned. If you don't have parentheses, the parentheses really say, no, I don't want the method, I want the values. Okay, so let's get to verified outputs. So let's get to Shiny Test 2. There are a couple of I don't want to call them bugs, but there are some sticky spots with Shiny Test 2 in packages. Snaps. You can see there are other branches. I invite you all to take a look at. Let's go ahead and load and build this. Sometimes I still need to install Chromote and Shiny Test 2, but I think we're going to be good here. So yeah, you want to make sure that Shiny Test 2 is installed. There is a similar to like a use this function, a use Shiny Test 2. What this does is it adds a setup dash Shiny Test 2 to your test that folder. This calls load app environment, which kind of just does exactly what it's describing. It's giving us the kind of broader environment for the tests. It's going to add these two, I would say, I call them suffixes or suffixes for snapshots you're going to ignore and your build ignore. It's going to set the active project. The biggest thing is it's going to add Shiny Test 2 as it suggests in your description, which is important because if I'm passing this off to another developer and maybe I've gotten through adding test that for the test suite, I want to make sure that I'm again managing the packages suggested in the description for testing along with the packages and imports for developing. Okay, so Shiny Test 2 does rely on this Chromote, this Chrome headless browser. You do want to do some setup on this. We won't cover it in the slides, but the Chromote package, I found most of the bugs were handled when I just did a remotes install for the dev version, but you do want to verify with this Chromote new session that you actually get the headless browser from Chromium that you're going to want to view your test recorder in. So those three little lines, once you've installed it, should produce just a standard kind of browser window that gives you some access to the source code and other kind of dev tools. But the biggest thing is if you see an error from that, you probably need to either identify where the Chrome is installed or some other kind of like inner workings of the test recorder and the Chromote headless browser. There's excellent documentation on Shiny Test 2 and on the Chromote package to get you set up with that. But the recommendation actually from the Shiny Test 2 author, which I really agree with, is that we ideally have one test recording per feature. Now, earlier I mentioned about having a module per feature, and it's probably too broad because modules a lot of times they like a function will handle a specific unit of work, but we also know that a module by itself is two functions and a UI, and it's automatically a bit of an integration test because we have a UI and server component. And I've never encountered or rarely encountered a module that doesn't also have some kind of supporting utility function. And so where system tests are end-to-end tests, which is what we're doing with Shiny Test 2, I really consider module tests an integration test because yes, we're only passing a single function to the module and the test itself, but it's integrating the utility function, and there's an assumption of integration with the UI. So I think it's best to kind of like mentally think of them as integration tests. But here's an example of a feature that we might use for just, and again, if we've been using this behavior-driven development syntax, it's really easy for us to give like a test script almost using these behavior-driven development scenarios for what should be happening when we want to record a test. So I won't go through it. I'm not even going to attempt to do it in here because this isn't I'm using Safari, I'm using Chrome. But when you run record test, the test recorder will pop up. The code portion here will be empty, and then you're essentially just you're giving the scenario of how to interact with your application. Now, the only things that I will say that you want to make sure you do is you want to make sure that you're exporting the values. So the buttons, there's expect screenshot and expect shiny values. I would limit the screenshots. Unless there's something very important about the display, I would focus on a way to, because the good thing about the values is that we can deal with them programmatically. We can do other things with those exported values. A screenshot is still requiring a human to look at it and review it and approve it. So this is how the test recorder works. Again, if we're using the behavior-driven development feature and scenario descriptions, this is just almost a straight script on what to do when you open your test recorder. Now, the test contents that are written from that output initially are just test Shiny Test 2. Obviously, we'll want more than one, so we'll address the name at some point. But the contents of that, you can see it's a test that test. It loads itself, but we can actually see the scenario in the code, right? We can see, let's go. Unfortunately, I took out the when, right? Given the mover application is loaded. Sorry, I should have left that one in there. But that's the app driver, right? So given that it's loaded, then the plot should show IMDb number of votes. So, this is literally walking through step by step what the test recorder is doing. So if you're using the test recorder as a GUI, you can go through and take a BDD scenario and create the test recorder manually, or you can also programmatically take a feature and scenario description, and you can use that app driver new, and you can apply the BDD functions directly to your system tests, which is really nice because like a lot of the time we want to have those bigger picture tests. This is really where these come in handy, is that we want to have a bigger picture feature description, probably more background, and then a step-by-step scenario of what we're going to be looking at with our application loading and the inputs and the expected values. And then of course, this is also where we've already provided a way in the example of sending the application to test mode, exporting test values. I'm not going to duplicate a lot of what Shiny Test 2 has, Barrett has excellent videos and documentation on how to use it. What I'm trying to point out is these test that behavior-driven development functions are excellent because a lot of times that it's hard to describe exactly what that system test is doing in the small text that we have and test that in the name of the file. or anywhere else. So you can actually describe a full feature and scenario if you add these BDD functions to your system tests. And I recommend obviously adding them all the way back to your module tests and unit tests, because we're rarely working in a silo, and a lot of times we want to make sure we're communicating to other developers, at minimum future us, on what that particular test was addressing in terms of a user expectation or need. And also it lets us know what's been tested, what hasn't been tested. Ties back to the traceability matrix, so we can have really clear descriptions of what the users and stakeholders have requested in terms of specifications, what capabilities we described in terms of features and included in the test description itself, and then where the rubber hits the road in terms of the functional requirements. Those are really your scenarios, the it functions, and depending on whether it's captured in a module or captured in a utility function, those are really the tests that we want to focus on. Whether you're using test-driven development, I just feel like it's like a myth. Like it's a thing that everybody says they do, but like I've always written them, if on a good day in tandem, where I know, okay, and most of the time it's because I want to make sure that I have this right, this particular specification and feature. I want to make sure that like this is the data they selected, these are the variables. So I'm going to write the test and make sure it verifies that really well articulated user specification. So I'll write that test and then I'll write the code and develop them in tandem. But I've never been write all the tests, write all the code. This is a great way because it gives you, first off, continue engagement with your stakeholders and your users, because many times we have an initial meeting, everything looks great, we do a wireframe, you disappear, you come back, they say that isn't what I requested, you say sure, and you go back and forth again. This is great because we can point to specific features that we've built based off their specifications. And then what's great about a scenario is if you write it in plain language, really clear non-technical language, given when then, there's very little room for ambiguity. It's just straightforward. When you're interacting with this particular dashboard or device, what is it that you want to do? What action do you want to perform? What inputs do you want to select? What data do you want to interact with? And then what is the outcome you want to see? And I've found that as a community, both as a communication tool with users and stakeholders, it's also great between developers, because you're writing the test that's checking that particular functionality, and they're writing the test that's checking that functionality. So that is the official end of the talk. I was going to say I'm 20 minutes over. I apologize. First for my tardiness at the beginning. I don't know why I had my. Well, I know why I had my. The source. I apologize. There's no excuse, but I have a young daughter at home that is constantly challenging my ability to operate on little sleep. So I must have somehow thought I started at 7:30. So I'm sorry.
No explanation needed.
But, what's that?
Glad. Hey, no explanation needed. It was only 2 minutes, so we're not going to hold it against you. So no worries.
Yeah, I mean, obviously, that was the 2 minutes that I was waiting for my coffee to kick in.
There you go. There you go. We always wait about 4 or 5 minutes for the workshop to start anyway. So I think the amount of effort and time and knowledge you have shared